Okay.
So now I'm going to start with the. So I wonder if you could successfully bringing that file and open up that project file on your machine. So if you did, the next step is to set projection, spatial projection in your HEC RAS 2D, and this is where you should go. You should open up a RAS mapper. So in order to open up a RAS mapper, on the HEC RAS first menu, just click on this that looks like multi-layer at the top of each other. So that will look like this. Could you reach to this point?
Yeah, it shows the mesh.
Okay. Oh, okay, because you should zoom out. But for the time being, it's not really important to have different view of this, but I'm going to set up a projection here for you, or you should do this on your side. The way to do this is to, on the RAS mapper, on your RAS mapper, just go to the tools, and click on the set projection for the project. If there is nothing here on your side, you should define a project, and I will let you know how you can do that. If it's GCS or if it's UTM, so you need to define it as a basic for your project. So please let me know what are you having on your side. Yeah, okay. So you're good. If it's already defined, that would look like this. If it's not defined there, you should go to your ArcGIS folders and find out the projection that you like to work with. If it's GCS, just assign a file or shapefile that does have a GCS projection, or UTM projection, I can say, and then bring it here. But if it's already there and it's all having these details, you're good.
So it will not work without a projection?
It will work with without the projection, but for some types of mapping and for some types of computation, having a projection is required. But for fast mapping, it doesn't matter. Okay. Ready to go? So
Now, we're going to add a terrain model, that's a DM, into our RAS mapper as a background image. And also, it's not a simple background image. You can add, here in RAS mapper, you can draw a line that is not a simple line, but a cross-section line, and then extract information from the terrain model. In order to do, prior to do that, you need to add a terrain model. So in order to do that, in a RAS mapper, go to Tools again, and click on New Terrain. If you did not assign a projection as we did earlier, but if you didn't do that, ArcGIS will bring up this pop-up notification saying it is recommended that the projection spatial reference be set before creating GIS. But if you had done that, you don't receive this pop-up image. But for those who had not done that, they will receive this. But click on yes, don't worry about that. But it is absolutely essential to have a detailed and accurate terrain model in order to create a detailed and accurate hydraulic model. And the quality of the terrain model data can be a limiting factor in the quality of the hydraulic model the user can create. If you have a 500 meter by 500 meter resolution DM, it's not good. Because your mesh grid, if it's less than 500 meters, it gives you nothing. But if you have 10 meter by 10 meter terrain model, but you have 500 meter by 500 meter mesh grid, is okay, because the mesh grid still acts like a cross section over a finer resolution terrain model. And HEC RAS uses gridded data for terrain modeling, so it's based on greedy analysis. And it is necessary to create a terrain model in HEC RAS mapper before the user can perform any model computation that contains 2D flow area. So the first step in producing your model is go to RAS mapper, bring in all these information that we're going to do, like terrain model, and then set it as your background, and then go to other sides like geometrical editor and whatever you need to do. So the first step is to bring in terrain model in RAS mapper. So this is how you can do that. So if you click on the terrain model, you will see such a window that will pop up. And in that window, this is the way that you can add 1 up to 100 terrain model that will sit at the top of each other. This order can be manipulated by user, and you can say, okay, I want to attach multiple terrain model together. I have a terrain model that have this amount of grid cells, and I want to attach it to another terrain model that is beside this, but have a larger or coarser resolution. So if you want to attach them, just add one terrain model as a separate raster file, and then add the other one as a separate raster file. Then you can order them. But the order does matter when you are seating one terrain model at the top of the other terrain model. And for example, you want to merge them together. For example, you have a terrain model that has a 100 meter by 100 meter resolution as a floodplain. And then you find out that, hey, I have some information about a river or the location that the river is passing through. And for those locations, I have some terrain models that would represent that location, that have a finer resolution. For example, like here. And this is one terrain model, T1. This is another terrain model, T2, and this is the other terrain model, T3. Okay? So you can add T2 and T3 and order them put them at the top row by means of these arrows, and put the coarser resolution at the bottom. Then they will be merged together. So I'm. Did you could you make it, or I mean, could you bring in that train model? You could go to.
There's like a bunch of them. Do we add all of them?
Yes, you should go. For example, that's what I'm going to do. You should go to new train model and click on this plus button, and here in this folder. So you have you had two folder: the Bald Eagle Creek Multi-2D and the test. So go to the test and go to this train folder. So you have a bunch of things here, but I will ask you to bring in one of them, not just. I'm looking for the one that is.
You want to change it to a list view?
Yeah, I'm going to do this.
Top right.
So, the one that you should bring in is called this one. Or I will ask you to do this one. Yeah, this one. Channel and overband. And when you click on that, it will look like this. It gives you information of cell size. And the projection when says same as the project, it is the one that you had already assigned when we had go to that first page. And then you can define the rounding precision. You can say, okay, if I have Z values for each grid cell, I can round them up off to say 1/32 feet. But I would recommend you to click on none and do not round the Z values of the cells.
So, Shahab, what's the background that we see? That's not a DM?
That's a DM.
So we imported
Yeah. This is the background DM. Suppose that you have I had added before, so it's not something that you will see when you start from the zero. But for example, I want to attach something to this DM, or I just want to add a new DM. You need to go to that new terrain model and then bringing those files, terrain models like this. And then you can assign a location where you want to save that terrain model. So I can say I want to create a new folder and call it terrain draft. So it will be saved as HDF file. I will explain about the HDF file next. So HDF file is an advanced form of raster file. Suppose, as I mentioned here, you have multiple raster files that are attached to each other. So the HDF file at the end is a single file but contains all these information for those multiple rasters. And it's good to know that you can also have another file called VRD or something VDF. That VDF file is also a good one to export it to ArcGIS for your personal mapping out of the RAS mapper environment. I will explain it. Don't worry about that. So if you click on the create, will produce that train, and it will say that the train complete. Okay, and then you would have a new layer here, and RAS mapper after the train group. So the first one was the one that existed in the beginning, but the new one is this. If you just uncheck the first one and just keep the terrain draft as you entered as it is, and you can zoom in by going to this magnifier button and click on that and then just zoom in. And if you want to zoom out, there is no button for zoom out, but you can just click on these two buttons that says zoom into half the current extent and zoom out of to double current extent, so that you can go out. Or you can click on the back button or forward button. Sure. So, this is how we can bring in a train model or a DEM model into RAS mapper environment, and then while it's here, then you can work on it on the other modules of the HEC RAS, like geometric editor that we will talk about later.
So basically what this step was, it just took DM, the TIFF, GeoTIFF file, and converted it into the HDF, which is kind of a native.
Yeah.
So that's all.
Yeah. So the other thing that I should say, it's not necessarily need to be a TIFF image. I will explain it. As I said here, RAS mapper can input train data that is in floating point grid format, .flt, geotiff or .tiff, that's what we did earlier, and Esri format, ADF. And let me just enlarge this. It also defines the elevation precision. You can define this actually of the new terrain data layer by means of that rounding precision radio button. But I recommend you to put it as none. And this allows the user to provide a name for the new terrain layer that you're adding. And also you should be careful that if you have not assigned a projection for your project, or that particular terrain model or whatever raster image does not have a projection, at this column projection you will find a warning or something like none. So you should be careful of that.
So the rounding precision you ask for none?
Yeah, you should do it as none, because suppose that we have a raster layer that if you have a cross section along it would look like this. Okay, so it must be a little bit better. And when you say rounding precision, it will round off this or cut them something like to just not improve the computational speed, but somewhat to reduce the burden of computation over the models. But it will affect your result. Do not do that. So could you build up your terrain model on the RAS mapper? So here I also put some more explanation for those formats of rasters. That floating point grid consists of a main file with the .flt file extension, and also they have a HDR file. All of them have a HDR file because that's the end result of the RAS mapper train generation. And also they may have a PRG file, that's a projection file if they have a projection. And if the floating point grid format file do not have is not the same projection as what has been set in RAS mapper, you should do this. And then the user must have a projection file that describes the projection of that raster, or you should go out of the HEC RAS and do this in ArcGIS and go back and add the revised form. So, and these are, I hope that you had done this by your own, but here, this is how you could change the order of different or multiple train models. If you want to put the final resolution at the top of the coarser resolution, you should go and use this navigation button to shift them up and down. And as you can see here, I need to shift the final resolution cell that is 20 feet by 20 feet to the top and put that 36 feet by 36 feet resolution cell train to the bottom.
Shahab,
Yeah.
if you have this example where you have two different raster resolutions, the output of that, the HDF file, will maintain the raster of each one, the resolution of each one in different locations?
So, okay, that's a good one. Because when you have a finer resolution, it will at the top and lower resolution at the bottom, and then they are merged. Suppose that this one is the finer, the coarser resolution, and then you have a finer resolution like this, and then another coarser resolution. So the final raster product, or the HDF product, will adjust the resolution to the final resolution, but these cells still have the original elevation.
So it will be a uniform
Yeah.
resolution.
So the finer one always affects the coarser ones, but just in terms of resolution, not the Z value. So can we proceed? Do you have any other questions? So, and okay, these are those two files that are the end product of the RAS mapper. That would be a GeoTIFF file. Whatever you had as an input originally, at the end will turn into a GeoTIFF file, and also creates a HDF file and VRT file. An HDF file stands for hierarchical data format file, contains information on how the multiple GeoTIFF files or different raster images are stitched together. And the VRT file, or virtual raster translator, is the one that you can take it into other environment like ArcGIS to do some mapping on that separately. And after train model data set is created, the user will be able to display this layer as a background image in a RAS geometry, a HEC RAS geometry editor. This is where you are going to add cross sections, or you're supposed to add cross section in 1D version. You can add it as a background image in that environment. And terrain layer and any other map layer developed in RAS mapper are available for display in HEC RAS geometry editor. So RAS mapper is kind of place where you develop all these layers, and then you can add them as a background image in geometry editor later. So now we are going to the geometry editor. Say we are going to using cross-section data to modify and improve the terrain model. One of the major problems in hydraulic modeling is that terrain data does not often include the actual terrain underneath the water surface in the channel region. That means the channel geometry. And the mapper can now be used to create a train model of the channel region from the HEC RAS cross-section and cross-section interpolation surface. So as you might know, all the DEMs will not penetrate the river to give you information about the channel geometry or the cross-sections. So the water surface will look like a flat level. But suppose that you have observation data for cross-sections for that channel, and you want to add those observation as a new data or as a new layer to be attached to your original DEM. That means you are going to carve the original DEM to define the channels or define the channel cross-sections. So in order to do that, you can go to geometry editor and then import those information of 1D cross-section data. So let me do that for you. So that was the RAS mapper. I will close this for the time being. So in the main menu, just go to this View Edit Geometric Data button and just click on that. So you may have a different view of this on your side, but don't worry about it. So first of all, if I want to turn on or turn off some of the background layers, just click on this button here. I will do this again, so just this one. And you can click on this or click on that other layers.
So are they the raster file? Background image?
Yeah.
Raster file?
Yes. And if you click on this and you will see that, hey, why it's not coming up, you go back to that RAS mapper again and click on this to have this as a whatever you have here. And then go back to geometric data editor. And then again, click on that plot train, and then you have it on the back. Okay, go to this option, and in that option you will have something like this. Check on those, or say uncheck this train draft as you generated earlier, but let this layer be on. So you have something like this in RAS mapper. Do not close the RAS mapper, just go back to geometric data. Go to this option, background picture on schematic, and then click on this that says terrain associated train in RAS mapper. Just check this on, and then you will have this on back. Okay. So now I will want to add. Yes.
When you go to RAS mapper and then we open this terrain, then I see the grid also. The grid was already done before.
Yeah, it was done beforehand. So
It doesn't develop.
no, if you have if you haven't done that, they will not be there. I mean, they will.
In this case,
Yes.
you had already.
Yeah, I just did this because I wanted to show you some background of that.
I was just wondering whether.
Yeah, yeah.
Thank you.
Sure. So now. I'm trying to bring in. Okay. So the thing that you should do, go to that file, open geometric data. Just select this one that is Bald Eagle Creek geom _test, and click OK.
Where? Can you
Sure.
step?
go to the file, open geometry data, and select this first option. And okay. So what do we have here? For better seeing what is going on here, I just turn off that background image to give you better view of the 1D cross-section data. So I'm just keep zooming in to show you something here. So
these are the 1D, familiar 1D cross-section data. Suppose that somebody gave you this information, or you generated these information by means of the observation data, and you wanted to attach or add these geometric information of the channel to the terrain model or DEM that does not have this types of information. But the thing that you should do is, these are 1D information. How can I turn it into a raster image that you can then add them as a layer in the same way that I explained? That if you have a hierarchy of high resolution and coarser resolution of the terrain model, this guy would be a higher resolution, put it at the top of the lower resolution, and in RAS mapper I'm talking, then generate a new terrain model that is the one that had the original DEM or and the new layer that is attached to the original DEM as a channel geometry layer.
And if you go to this channel geometry editor and click on this cross-section button.
So how can you generate the raster file from the cross-section?
I will explain it. Just want to, because I think some people have no idea about the 1D raster is either. Sorry, 1D HEC RAS either. So in that button, in that option, you have the information of that cross-section. It will give you the stations. Each of those points are the stations of a particular cross-section. It starts from the upstream and goes through the downstream. But you can navigate through those cross-sections. Click on these up and down. So if you click on those, up and down button, you can navigate through cross-section from upstream to the downstream. And you can see, if I zoomed in again to one of those environments,
so that's one of the cross-sections. These two red dots shows that this is the bankful stage. This is the main channel, and these are somewhat the overbanks that is observed or captured by the observer who had collected these data. And you can see here too that this is showing you the cross-section at that location, and these two red dots said that, okay, this is my bankful channel, and these are the floodplains. And also, you can see something here as a gray color line. That is your ground, or the train, or the DEM that you were you had that prior to my effort to turn it off. So that train model will be highlighted here also as a gray color line, and you see that there is a kind of discrepancy here, although the terrain model is not. That terrain model has already the channel because I had diffused them before, but the original DEM will not have that channel. It will show you a kind of a flat line here because it will not penetrate water.
So now let's generate a raster layer from the cross sections. Getting back to here again. So in order to do that, you need to bring in or import the existing 1D geometry data. So in order to do that, in geometric data window, go to the file, and in the file at the near bottom you have option have an option that says import geometry data. And in that you have multiple options here, but the one that you are going to work with is HEC RAS format. Just click on that HEC RAS format. As I said, somebody had generated this geometry data for you before. He had an observer who went on the field and captured those observations and produced those data in terms of HEC RAS geometry data. You might have a CSV file that is containing some elevation data, and you can also use that. But here we are going to have
CSV data is format like that long and
yes, yes.
Like XY.
It's somewhat XYZ. Yeah, it's somewhat XYZ.
So it has to be from.
It's like ASCII.
So you have to be cross section.
Yeah,
No random part. And I have a definitive one, random definitive one.
yeah. So let's do this on HEC RAS.
So what we did with the open before, that was basically a step after.
Yeah,
that
a step
was
after.
already compiled.
Yes, it was already compiled. So now let's go to this and import geometry data, and also click on the HEC RAS format. So now what we're looking for is a geometry data. So go to that geometry data folder and click on the Bald Eagle Creek geom test. Then this window will pop up. So it asks for the what was the unit. So it is US customary unit. So it's already selected. Click on next at the bottom. And it gives you information about the reach streamlines. So everything is set and is there because somebody else had generated that geometric data earlier, so it's there. So just keep it as it is and click on next again. It gives you a snapshot view of each cross-section and their information. You can navigate through and see what is going on inside. And also gives you information about the precision of the values, if it's 2 decimal places, or you can turn them into other precisions. But I suggest you to keep it as it is. If that geometry data does have levy information, bank station, Manning value, as this data does, just keep them as it is. But if they are not there, just uncheck them. Do not complicate things. So you can just click on the finished and import data button. Where in the list? Oh, this one? Oh.
I think because it's already
Oh, okay. So, so suppose that in your geometry data, okay. Suppose that in the geometry data you have a tributary and a main channel. So you have a main channel like this, where you have multiple cross section over there. And then you have a tributary attaching to that main channel. And it does have also another. In HEC RAS 1D, you can label this guy as a tributary and this guy as a main channel, and these two can be separated in terms of geometry file. But they're all in the same editor, but they have the same name, but they have a different file. And you can navigate through either of them by this import river and import reach.
Talking about the import status, your column and then,
Oh, this one?
yeah, next to it, import and next.
Okay,
Import
so
status and import data.
back to the here. You see these labels?
Yeah, this process and all.
These are the labels that that are reported at those two columns, and you can edit them, but not. You can edit them here, not in that window. And it's something like this. If you start with, if you can say start with 1,000 here and add 0 here, and based on this hierarchy, it will say, okay, based on the distance between each cross section, that would be 999, that would be 970, and it depends on the distance, and up to it reaches 0.
What is that one? Oh, it's the from downstream.
Yeah. 0 is the downstream, and 1,000 can be the high. But here's not 1,000 or 0, but I'm saying this is how it will label the cross section itself, and you can edit it. So, okay, we did that, and we just need to click on the finish and import the data. So it will give us a notification that the following internal boundary nodes already exist in the current geometry, but import these internal boundary nodes will replace. You can click on a yes and don't worry about that. Okay. So now we have imported those data from other files, from other sources into the current project. And we have them here. So let's see how we can develop. The next step is to see how we can generate raster image from these 1D geometric file. So this is what we had done. These are the steps. And we imported those data into the geometric editor. Now, we are in a, the next step is to go to the RAS mapper again and apply the information that we already imported as 1D geometric data in RAS mapper and put them in RAS mapper, and then develop the a new train based on the 1D information. So let's do that. You can see the snapshot here to, and you can follow this image to see where you should go and what you should do. The thing that I'm going to do is to open up a RAS mapper, and in that RAS mapper, you will see that there will be a new layer here at below the geometries. Okay? Could you find it? So if you expand that option called bulk river creek or whatever, you may see just only 5 to 6 options, or these are the layers. Suppose that it's ArcGIS and you're watching a layer below a layer, feature classes below a layer. But you can also see a triple dots here. So double click on this, as you see here. If you double click on that, you will see a new window will pop up. Now you have some options here. Please turn on river, bank
2D flow. As you turn them on and or off, check out your RAS mapper and see if you can find out new updates, or new updates are coming up in RAS mapper. Yes? Oh, and I did not bring the geometry here. I asked you to go and import. Where did you
Just show the boundaries.
No, who had a problem so far? Who had no problem? Are you looking to see how you do it now?
So Now I wonder if you could bring up those layers into your RAS mapper. If you could. Now, in the same RAS geometry properties window that you just opened up, click on that XS interpolation surfaces option. Could you find it? Okay. So when you click on that, you will see there will be like a shading type of a layer that is added to your. So these shadings are actually the finer cross sections between two cross sections. So you have a little shade here and a little bit gray scale here. So these are finer cross sections that are between two cross section, and then RAS mapper will, based on this shading, will generate a raster, and that would be your channel floodplain layer as a raster that you can add to or attach or diffuse with the original DM. So let's do that. So now I'm on HEC RAS side, and I'm going to go to RAS mapper. That was river. So my river looks like blue because I turned it into blue. I think yours also blue. XS, so that would look like this. And when I click on XS interpolation surface, that would look like this. So if I zoom in, you see these are. So so these will be filled by a rasters, new rasters between each cross section. So the more closer your cross section, the better the resolution and the better the data. The coarser, that means if the cross section are far away, so it will base its interpolated layer by means of that to upstream downstream cross section. So now, in order to export it as a we had done that. In order to export it as a new raster layer, just right-click on the layer having the name of that project. So in below the geometry in RAS mapper. So I will do that here. Just right-click on this. So these are the options. You have RAS geometry properties, zoom to layer, remove layer, move layer, and export layer. So this is what we're going to do. This modification. So these are two options that you have in order to generate a raster from the 1D geometric data. You have create terrain geotiff from XS's, that means cross sections, including overbanks and channel, or just only channel. Remember that we I explained it that in HEC RAS, if you have a cross section, it would look like this, and you have two dots here, red dots. So those two red dots specifies where is the main channel and where are the floodplains. And when you say from the 1D data, just develop raster based on channel only, that means just keep this as your limit. But when you say over banks and channel, that means include also those other extended cross sections. So let's just develop one for the channel only. But at the end of the day, I will recommend you to just do, if you have information for the overbanks, just choose channel and overbank. So it will ask you where you want to save that geotiff file. It will export it as a geotiff file. Whatever data it is the input, it will export it as a geotiff file. So I may ask you to create in that terrain draft folder that you created. I will type terrain draft channel. And click on save. So it will ask you what you would like the grid cell size be. So just be careful of the unit that you're dealing with here in this project. It is English unit. So and also see or recognize that your terrain model for the whole domain is 20 feet by 20 feet, at some point 30 feet by 30 feet. So it's better to have a lower resolution for the channel, up to similar resolution like what you have for the terrain, but do not use something larger. So here I would put 20 feet. So then click OK. Then it will So let's see what's the next step. So the terrain model is created by taking the elevation data, as we did, from the cross-section and using the interpolation surface to those shady region to interpolate an elevation, to interpolate an elevation for each grid cell between two cross-sections. And now you should go to you should go to now we're going to import that new layer of terrain into RAS mapper. So in order to import any types of geotiff into a RAS mapper, you should go to tools, as we did earlier for importing that layer of terrain. Just go to the new terrain option in the tools, and the same way we had saved that new layer of channel into terrain draft folder. Here it is. So let me, as you might expect, yeah, this is the one, terrain underscore draft underscore channel we already created. So click on that and click open. And as I suggested, you turn it into none, the rounding precision. And also you can go here and change the name of the final HDF file. So I will also call it as we call the geotiff file, terrain channel, but just remove that extension at the end, .tiff. Okay, so you have something like this. Then click save, and you have it here as you see in the bottom as a file name, final file name, and click on the create.
So that's only based on these cross sections. It looks much smoother than the interpolation, but the grayscale thing is.
Oh, okay, maybe I was not really clear on that. These are not, okay.
These are not elevation.
These are elevation, I mean, so, okay, that's good. So between these two cross-sections, this shading is not kind of a millions of cross-sections, something like you might imagine, but it will says that between the two ends of two cross-sections, this is the region that it will generate those types of raster. But because you said it's 20 feet by 20 feet, it will adjust it to that range. So as you see, we imported that layer, new layer, terrain layer, into our terrain sublayer. So I would turn off all these layer, go to this geometric layer and turn off that excess interpolation surface, and or I can say just turn off the whole thing, turn off the geometries. Okay. And turn on in terrain layer the terrain underscore draft underscore channel as we had imported. And click on that world shape button and you have a world view of the domain, and then you can click on that magnifier button and say, I want to see what is going on here nearby the channel. So this is actually the reservoir behind a dam here. And you can also add a legend to this, but I wonder why it's not there. It's supposed to be there. Oh, okay. So in order to add the legend, you also need to click on that layer. And if you click on that layer, that legend would pop up. You can see. You can turn that legend into different color. Just double click on that. I will talk about it later, but for timing, you can double click on that legend and turn it into a discrete instead of being stretched. And just close this. Then you will see the difference as I zoom in. You can also change the number of intervals from 5 to 10, then it will look like more smoother. Or turn it into 40. Let's say 10 is good. But I don't know why it's not. What's that? Oh yeah, that's plot contour, sorry. I may go somewhere else. Okay. Go to edit. I'm sorry. Go to edit. Now turn that number of values from 8 to 20. And click on create. Okay. And click apply. And now, if you want to add contours, you can say, I want to have a contour having 10 intervals. You can uncheck the plot surface and just have the contours. Okay. So you can do a lot of mapping things here in RAS Mapper than going back to ArcGIS. So we just developed that new terrain based on channel information. And you can do the same thing, incorporate by also adding the information from the floodplains. As you can see here, you have the main channel from red button up to other red button on the left and right bank. But you also have floodplains data. Then if you want to add them, as the same way that we did for channel, just you need to go back to the geometric editor. So you had the information here, and you need to say, okay, I want to add in RAS Mapper, I want to add in the channel plus overbank as a new raster layer or terrain layer to my data set. So again, go to the new terrain. Maybe not new terrain. Maybe. Oh no. I was wrong about that. So. You need to go to probably that new terrain.
You need to export it.
Yeah, you need to export it first. That's what I'm trying to. Okay. No.
Yeah, right click on the job.
Okay. Oh yes. Oh no, but it was not the way that we did it.
Yeah, right click on the geometry layer and export, and then export with.
Oh, you're talking. Okay. You're talking about the. Okay. Yeah.
How come the raster look like that?
I'll just
Okay. So now we're gonna also add in the overbank and channel together as a new terrain layer into our RAS mapper. Oh, RAS mapper. Okay.
How come you create that look like that? What I gotta expect why you got like that? I got like
Oh, okay.
cross section.
Could you please, that's what you should do. You should double click on this. No, sorry. That's double click. Try to do that. And go to the layer. Okay. Then you should turn it from stretch to discrete. And if you just want to see the contours instead of the layer or surface, just click on contour and turn it up. And you can change the interval. It's not elevation. It just shows what are the domain between two cross sections where it's gonna generate the grasses. It's not elevation layer. Just says what are the domains in which we're going to develop the terrain from one divided up. No, the color does not does not matter in terms of so that says from white to the darker shade, we are going from upstream to the downstream, upstream to the downstream, upstream to the downstream.
That's not elevation.
That's not elevation. That's just what I'm saying.
What is the melody from white to black?
It's just showing a graphical snapshot of how upstream to downstream elevation progress. Yeah. It's not actually. I think it's confused because
You import from the project. You import the elevation point from the project.
yeah, but it's each cell of this shading does not mean any elevation. But for showing you what is the progression from upstream to downstream.
This is the extent of that.
Yeah. Yes. option to work with
It's
those.
actually very
I'm
pretty
guessing
close
it's
to the Georgia
one.
and
Yeah.
Tennessee border.
And then they convert to raster.
Yeah.
But it's just, it's like.
My suggestion is always work with TIFF
So
file.
you can't use
Yes.
Not bring it as other format. I don't suggest
all
you
of
do
the
that.
federal like
So you, why you having to that? Why you bring you the channel
Yeah.
plus overlap? You show the channel.
like the side, like
Because if the channel is
and
just
Yeah.
have to like
Yeah.
climb
say
up the whole
channel plus
section.
overlap.
Yeah, because if you have already had information from the overband, why not to bring it because the detailing observed.
Like makes sense. Like that,
I heard, as I said, it is better at the top.
So you bring at the first time channel plus
Yeah.
overlap. You do second.
Yeah.
Yeah, it is. The unfortunate part
Can
is
you-
Alabama. Yeah, the state part.
Like just bring the one, you know.
Yeah, it's really sad. It would be such a nice
Ah,
part.
okay. So it's as editor, geometric editor. So you're here.
Instead, he gives us access to the right? Yeah, and there's like a special
So
that
this is
But I think you've done part of that.
just to have this.
a lot of people do.
Yeah.
But you know, there's no facilities.
Yeah, no bathroom. It's like, well, that didn't actually increase funding for the state parks, but it did just say you can't raise the state park funding to fund other things.
Yeah.
So yes, small victory, but it didn't actually increase. And like they're doing triage on their state parks because they just don't have any money. So like they're trying to like
These are the bands.
the ones that people go to. Really nice, which they those ones are really nice. But then all the poor little ones that are on the door like this one kind of playing and die.
From what I understand, isn't it?
Really?
That's what they were saying. Like, I don't know what.
Well, like opioids.
Yeah, it's like a couple around there. That's like,
Yeah.
it's just very.
It is
Yeah, if you're
very
doing, if you're doing like
I mean, it's like incredibly.
Just get rid of that.
Definitely
Develop,
like,
yeah,
smell
like the
like
way,
all the
yeah,
stuff
very,
and
very,
stuff where, I mean, it's like,
think of a human.
Oh, the rock school.
yeah, absolutely. Yeah, the landscape is
one separate
incredibly beautiful.
interferes with others.
In what country is this? Oh, I was gonna say, I'm like, in America.
We are only in page 41 and we have about 116 pages. I'm just wondering if I'm on a good.
Well, I mean, you have multiple examples, right? So maybe you don't have to do it.
Like an audio book.
I think you don't have multiple examples, you're just working on some example.
The idea being that this is all private land, and that's why people don't actually see it.
So I'm going to continue by, I think it's easy now because we already know how to import a 1D information from geometric data into RAS mapper. So last time we just imported that by means of using information of 1D to import just channel data as a raster. Now we're going to add it as a channel plus overbank data. So we had not done that yet, but we was in the middle of that. So we should go to here, just right click on this, and here, as we did, export layer. Last time we chose this one, channel only. Now we're going to choose over banks plus channel. And we are going to set what geotiff, what is going on?
Change folder.
I know, but I'm wondering why is not. Okay, okay. So I'm going to here. I will call it channel, and and overbank. Save it as it is, and the cell size, it must be 20 feet per time 20 feet. So just add 20, click OK. Okay. So it's there. Now we need to add it as a layer in terrain sublayer. So right click on terrain, and this time I will do this way. Add existing terrain. Go into what you had where you had that new terrain draft. I had it as oh, why is not there? Oh, because it's okay. So we need to first develop it as a HDF file. So go into tools, new terrain option, and so click on the cross button and select the terrain draft channel and overbanks. That is a TIFF file. We're going to generate a GeoTIFF file. So set the rounding precision as none. Change the final HDF file name as click on what we had as terrain draft channel to expedite your work, and then just add and overbank to this. And then click save. Then you have it here. So everything is set, is ready for to be created as a GeoTIFF file. So I will click on create. Give him some time.
So this is no, I mean, you don't need both, right?
I was explaining to him that sometimes you have information about the overbanks and you're trusting those information, so adding both together.
Yeah, no, but I mean, when you run a simulation, you probably just need one of the two.
Yeah, one of the two, yes.
So it's completed. So click on close. So now you have it here as a new layer. So in order to check it out, just as we did, uncheck the geometries and also uncheck the terrain draft channel. So originally we had this, but it is not in the way that we are looking for. So I'm turning it back into what it was. So I'm a little move it up. Okay. So that was the one that we just generated by means of just channel information. Now this one is based on a new data that we are also adding the overbank information. So also because I showed that to him, I would like to show it to you too. So suppose that we have multiple layers here in terrain, and you want to see in a snapshot view of a one user-defined cross-section over one of these domains. Okay, so go to this measure distance button and click on that, and just if you like, just start from here in white up to somewhere on the other right side, and just one click, and you can just do this like that. And when you are done, just double click. Then you will have a pop-up window. It will give you what was the measure line length in terms of the unit that you specified. So we had US customary, so that is 12,000 feet. So you can add it as a save profile lines that would be added somewhere here in as a profile lines as one of these options. You can copy the coordinates to a clipboard, and you can go to a spreadsheet and paste it. And now I want you to click on this option, plot terrain plots. So you will have a snapshot view of that plot, of that cross section. And you can also have it as a table. Just click on that table tab. You have the name of that combined. You have the name of that cross section or the train layer that you generated that cross section over that layer. You have the stations and you have the train Z level values associated with each station. You can copy them. Just when you click on this, it will select them all. Just hold Control and press C on your keyboard. Then go to a spreadsheet or Excel, whatever you want, wherever you want, and then paste it.
So what is the two tab button here, left side, combine table and train draw? What is the two table tab?
So the combined table, and if you click on the combined table, it will just give you, if you have multiple, say if you have, I just have one layer here. Okay, if you have multiple layers from different cross sections or from different, I mean, if you have not different cross sections. Yes, if you have different trains that are not off, if you turn them on too, you can. Okay, let me do that. Yeah. So I have this one in below. No, not let's put it below. So you should go here and go to the move layer. Click on the button, so it will put that layer at the bottom. And this guy is at the top. See? Now, if I do this again, create that measure line at the top of these layers, double click on that and go to this plot train profile. So you have, I wish if I had better color, so I'll do this again. Oh my God, it's not, okay, doesn't matter. So we have something like this. So you have zoom in by just scroll button on your mouse, and then you can, yeah, that's it. So you have one layer at the top, one layer at the bottom, and you can see their names here also as legend. And if you go to the table, you can have them here. So when you click on that combined table, one column gives you the information about one train layer, and the other one gives you the other. And you can also say, no, I don't want to have them both. I just want to have something for one layer. Yeah. So let's continue. So we have done these.
If we have defined resolution train, so what is the interval? Interval will be like the table when you plot X cross-section interval. It will be defined same interval.
I think, as I experienced, it will be based on the final resolution, and then if you zoom into that image, you can check it out. At some point, when the cursor resolution sits on the final resolution, you will see a smooth for the cursor resolution, but you will see some oscillation for the final.
Yeah. So I think we had done these pages, and we are going to now set up our hydraulic models. We just set up the geometry. So so in order to set up a good hydraulic geometric model, you'd better to also add a map layer behind the RAS mapper to see what is going on there, and if you have any hydraulic infrastructure, if you have an obstruction or whatever, where are those? And we can set up some polygons around them and then export them as a layer into geometric editor option of the HEC RAS, and then develop our geometric and profile information at that side. So in order to do that, you should go to the RAS mapper. I'm just turn off the terrain layer. So I'm now going to add a map layer as a background image. So if you had these options, you're good. If you don't have this option and you want to add a background image from an online source, you should right-click on the map sublayer. You have these options. You have add map data layer, add web imagery layer, new land cover layer, existing land cover layer. We will work with all of them. Now, I'm just going to add web imagery layer. Just click on that. So this is the option. These are the options you have. Okay. So you can. I don't know. I will work with Google or ArcGIS World Imagery. I will go for, because I already have Google here. So I will go for ArcGIS World Imagery. And you have also an option, say, reprojection resample methods. You have near, you have average. So I will go with near. And let's click on OK button. And I should turn on my map layer. So it's like this. So you see we have a dam here. We have a lake behind the dam. And if I go up, this is my extent. We have levee here. So that's my layer. So at the top of this layer, I can add my geometric data. So this is my geometric data.
Yeah, so some people may not have internet.
Okay, if you don't have internet, I wonder if you can still. So if you don't have internet, you can still work on this Google satellite layer. Is it working on those machines who doesn't have? Okay. So if you're okay with this, we can proceed. We are going to develop a 2D computational mesh here around the domain that we are going to simulate our 2D model. The user most likely select a nominal grid resolution to use, and the automated tools will within HEC RAS will build the computational mesh over that. After the initial mesh is built, the user can refine the mesh grid with break lines, and I mean, if you have these types of square, you can add break lines to turn their orientations. I will do that for you to show you how it works. And also you can add the background, as we did, background true color image of the natural topography, like Google Map image, to better delineating 2D computational mesh boundaries. So let's see. So this is how you can add in geometric editor. Not now. We are talking about geometric editor window. So we are in geometric editor window, and we are going to add that mesh grid, 2D mesh grid, at the top of this. So I want you to in your geometric data, go and create a new geometry data. Just click on this. At File, New Geometry Data. So it asks you, do you want to save the existing geometry data? Say yes. And now we are going to generate a new geometric data, and these are the places that you can add that geometric data. I may ask you to create a folder, a new folder, while this option is selected, Bald Eagle Creek multi 2D test. That means that new folder will be stored in that place. So create folder button must be clicked. So you just give it a name, say geometry data underscore test, or draft, I will say draft. Click OK. So that's new folder. And then I'm going to name my new geometric file as the same. Geometry data draft. Click OK. So you have a blank page. So here I'm going to add a background image. Because I already set all these background and all these layers in RAS mapper, you have this option here, these options here. So I want to add a background image like a Google satellite or ArcGIS World Imagery. I may select ArcGIS World Imagery. But if it's not there, that means you should go back to a RAS mapper. And that's good to learn. When you see there is no connection between RAS mapper and geometric data editor, that means they are not associated. You need to associate them together. In order to associate a RAS mapper layer or RAS mapper information to another geometric data, go to RAS mapper and right click on geometries or geometries, sorry. If you right click on geometry, you have an option called Manage Geometry Associations. Click on that. So you have these options for different geometry layers. So you can specify what terrain to be associated with a particular land cover or a particular RAS geometry. As I see, everything is set here and is okay to proceed. But we will be back here again if we face any trouble in the future. So back to here in geometric data editor window, go to the file and I wonder why it's not there. Go to the file and click on the open geometry data. And go to that Bald Eagle Creek Geom Test 2. Click on that and click OK. OK. So this is already made here, but I will let you know how you can generate that mesh grid. If I just zoom in further, you will see that mesh grid area here. But I'm going to generate this types of layer again. Go to the full plot. So in order to do that, I want to turn off this layer of mesh grid and want to generate my own layer. In order to turn off this already existed layer, just go to GIS tools, or say, why is okay, no, just click on that geometric 2D geometric data, and I don't know why it's not there. Oh, okay. Go to the view. So that's my bad. Go to the view tool and click on the set schematic plot extents. So click on set the compute extent so you can what? There must be an option to show me how. Okay. In the view, go to the view options. Okay, that's where I should go. Okay, we're good. So in the view options, that's where I was. Go to the view in geometric data and click on the view option. So you have these things to check or uncheck. At the storage area 2D flow area properties part, just uncheck 2D flow area cell points and fill in the storage area or 2D flow areas option and other options. And then I'm going to add a new 2D flow area to this based on this background image. So in order to add that, you have this option here, 2D flow area, that if you hold your mouse cursor at the top of it, it will says add a new 2D flow area. So click on that, then the cursor would look like a pen when you do that.
Don't you need to open the file that you just generated, whatever draft? Because otherwise, isn't it going to edit this text, the whole legal print?
Yeah, I mean, if I'm just going to expedite the thing, because in that new geometric data, you need to do whatever I did to add terrain, and this is the way I wanted to show you that if you want to generate a new project, a new geometry, you need to go there and just add those layers. And I just want to expedite, like someone who was made something and want to just jump on the already made things. But this is how you should do that. So suppose that you have this background template, and then you want to add based on this background template, you want to add similar to the shape of this background template, a new 2D flow area. So when you click on this, the cursor will look like a pen, and then you can start from here. And in the beginning, you'd better to zoom in first. I will do that again. I will zoom in to give you better view of this. Okay, if you zoom in further, actually that's the tedious part of the HEC RAS 2D. You need to draw it by your hand. And
Can you, doesn't it, is it a problem if you just do just a long general area? Do you need to be that specific about the location? I just, straight line all across the
you can say, okay, it causes more time compute.
Yeah,
You can say, okay, I want to just draw something like this. I want to just draw a rectangular, and then just name it, and then it will. But some of those places will not or will never be inundated, and it will put more burden on HEC RAS to compute zero flow cell. But if you are
But
not,
that's the only disadvantage.
yeah. But the good thing is that some people may say, okay, I'm really curious to see what is going on here when I have already a polygon that is produced by somebody else. You can add that polygon as a separate layer here, not a computational layer, and just follow that polygon and do it faster. That's what I'm doing right now.
How do you know that you won't draw the polygon too small? Is it like the one you have there is based on a DPM? Or how do you know how wide it should be? If you don't have this blue mesh there, if we just have this background map, how would we know if
Okay, so this background map is really broad, and but the DEM also might be somewhat a large extent DEM, but it's up to you that how far you would go up and down, and because we already had that 1D geometric data, that 1D geometric data is limited to that location. It's not going up and down further.
I mean, how wide? I mean,
Oh, you
if
were
we're
talking
looking
about the
at
width of
here,
this?
how wide should I go? Like,
So
you
if-
said that you can just take a huge area, but then you say, well, it was
Yeah,
heavy,
it-
how do you know it's not too small?
So it depends on the terrain. I mean, if you have, say, a terrain, if I have a cross section like this, people argue that if you have a wide terrain where you have a high elevation points, and if you're going to go beyond these elevations, go up to you find another high elevation point and set that. And that's why, for example, here, these are high elevation points and these are high elevation points. You can see that I try to be within this valley, not going up and down, because if there's an inundation, water will really jump through the mountain and go to the other side. And that would limit my domain. It's up to you how you want to go. But if you have tributaries, you better to also go beyond those limits. Did I answer it?
Yeah, I'm still thinking though, wouldn't it be better to somehow define it using DEM instead of me sitting there being like, well, maybe this is a good, it becomes very subjective if you're like, yeah, this tributary should maybe be included, not this.
Exactly, it's very subjective. It's up to a user where or how he or she want to define his or her domain. And in my experience, my little experience was that for those types of problems that you have tributaries, you better to extend your, you want to take into account the effect of tributaries, you better to extend your limits. But if you're just working on the main channel and you're within a valley, just be inside the valley. Rarely go up to the valley. If it's a really large flood and the slope of the valley is really steep, it's really insignificant change if you add those or extend your boundary. So I was in the middle of, so I think you grasp my aim here. I wanted to generate a 2D flow area. I just wanted to follow this template. And if you go and round it up to the same place, came across the same place, and double click on that, it will ask you for entering the name for that new 2D flow area. And when you add that, it will be added something like this as you have here. But let me do this a little faster here. Not in detail, but I want to proceed into different steps. Okay. So if I Okay, and now I'm closing this polygon. So then double click on that. I will say geometry flow area, 2D flow area. Click OK. Then you have this as your new polygon. So if I go back to the view again and just change the these options, so then you see this as a new flow area that does not contain any mesh here for time being. I'm going to add as I have for the lower layer like this, I want to add meshes to this area. I did not do this yet. So yeah, suppose that we had made that new flow area like this, that is pure blank with no mesh grid, by means of adding or using this option in geometric data editor. And as you saw, you will be prompted to specify a name for your mesh grid, so I did that too. And I also pointed out here that 2D flow area must be within the train model area. If the train model
Shahab,
yeah.
so can it be like, for example, if I have a GIS map and I know I have a GIS shapefile and that is defining the model domain area, can I import the shapefile instead of drawing?
Yeah, exactly. Yeah. So this, if this is the DM, and these are not there as an information made by DM, and if the geometry 2D flow area go beyond this DM, then it will give you an error that you must generate that 2D mesh within the terrain or whatever layer you have. If you have a land cover, also for land cover it will assign something if there is no value for land cover, but for terrain it's really important to have that geometric 2D flow area within the terrain extent. So the user must add 2D flow area polygon to represent the boundary of the 2D area. And the user may want to bring the shapefile, as we did, that represent the protected area to just follow those boundaries to generate or edit his or her 2D flow area. And the boundary between 1D river reach and 2D flow area should be high grounds, as I said. That separates the 2D and 1D flows, 1D area. For levees and roadways, this is obviously the center line of the levee and the roadway. So the next thing is how to add break lines prior to generate a mesh at the top of existing hydraulic infrastructure. And then when you develop a mesh afterward, those mesh will be aligned along with that break lines and also the boundaries of the mesh grid. And also those break lines that I'm going to show you how you can add them should be added to any location that is a barrier to the flow or controls flow or direction of flow. And they can also be added after the main computational mesh is formed. You can also say, we're okay with the mesh area that we have right now. I want to just generate the cells right now. And then I want to add break lines later. But I'm going reverse. I'm going to add break line first and then generate the meshes. So the break lines can be drawn by hand in geometric editor, or you can add them from a shapefile. So I will try all these options for you. I'm going to add a break line as a shapefile.
Shahab,
Yeah.
can you give more clarification, because you're talking about the previous slide you mentioned that the boundary between 1D river ridge and 2D flow area should be high ground. So when you're talking about the 1D river ridge, did you allude to that like the separate network, or you're alluding that the 1D river network within the 2D domain?
I'm talking about the 1D within the 2D.
1D within the 2D?
Yeah.
Because
Are we doing the
it depends. It depends. If you're generating a 1D, 2D model, that means you have a 2D flow area and you're attaching a 1D to that 2D. It doesn't matter. But when you're talking about you are having a 2D flow area and then you're going to add something inside the 2D flow area, you better be within these the topographical bounds.
But 2D will cover everywhere.
Yes.
And 1D underneath.
Yes.
Okay, thank you.
So now I'm going to add a shapefile as a layer to the geometric data editor to be regarded as my breakline. So in order to do that, as you see here, you should go to the RAS mapper and to the map layer sublayer. And then right click on the map layer sublayer and choose the add map layer, data layer. And then by clicking on that, a new window will pop up. Then you can choose your .shp or shapefile as your breakline. So let's do that. So you will see a levy here that I will bring it as its outline as a shapefile. So I should go to the RAS mapper and let me just align this to that location too. Okay, there we go. So go to that map layer and click on Add Map Data Layer. Once you right click on the map layer, you will have these options. So click on the first one. So you have something here as Lock Haven Centerline. That's the name of that levy over there. So click on that. I already have that file there, so I will turn it into, I add another term to that as a draft to see that I imported that. So you see all these are in terms of shapefile, but they're AutoCAD shapefile. So click on this and turn it to name. I did that. And click on open. Oh, maybe I just need to just set it as it is. Okay. You cannot turn the name. That's interesting. Okay. So it's there. Now it's at the bottom of those layers, so you need to put it at the top. So right click on that new existing layer and go to move layer and select the top one. And if you could not find it, right click on that and click on zoom to layer. It's like ArcGIS. Okay. The reason that you cannot see because the color is white. So I should double click on that. You should do the same. If you have a different color that you cannot recognize it. When you double click on that layer, you have these options. So the line also can give you the option to change the color and change the width of that line. So I'm turning it to red. And I also change the width to 2. You can also change it to be solid or transparent. If you have a layer and you want to see the below layer, you can also make it as solid or transparent to check out the below layer. So see, you have now the levy outline. This is the levy outline. If you hold the cursor at the top of these lines, you see they will be highlighted in purple. Okay, so you added a shapefile of the Levy outline to the RAS mapper. So the next step is to see how we can export it into geometric data. This is what we did. So back to geometric data. Let's go back to geometric data. So we are on geometric data editor. I want to add that already layer that we generated as a layer at the top of these 2D areas. See, we have this here. But because we changed some options in view options, that's why it's not showing up. The thing that we did, we unchecked the display break lines used in 2D flow area. If you check it on again, you see that will appear. See, if I just do this, it's there. But don't be confused. I did not generate the mesh grid yet, but these are already made. I did it prior to this lecture. But suppose that this is the red line is the one that is just a layer. It's not a break line yet. It's just a layer, and we are going to use it as an outline to draw our break line at the top of it. Somebody had gone on a field and captured the crest elevation of the levee and just gave us some elevation and coordinate points, and then we are going to generate our levee along with this layer. That was a shapefile.
So the shapefile that we import is basically the crest length
Yes.
of the levee.
Yeah.
Now we need to generate the break.
Yes, at the top of it. I just want to use it as a sketch or as this kind of a guideline. So in order to do that, you can go to the GIS tool. Let me just enlarge it a little bit. I wonder if there is any way to, okay. Oh, shoot. Okay. So in, I wonder if you can see it. So in geometric data editor, go to the GIS tools and then click on breakline coordinate table. Then once you click on that, you have, you have these. Actually, firstly you have this window. So if we did not have anything yet, it's supposed to be blank. Nothing's here. And you should import lines. The only thing that I did earlier is to just bring in an outline of the shapefile. Now I'm going to use that shapefile that I bring in as an outline and use its own coordinates and its own elevation as a sketch or as kind of information that HEC RAS geometric editor will generate a kind of a break line based on that. So if you can find that Lockhaven centerline shapefile, just click on that and click open. And so once you do that, you would have it as a breakline layer in to your geometric data editor. But suppose you're not lucky enough to have that information and you need to draw it by hand. So that means you need to have a layer, a map below, and then just go to zoom into that layer map and draw it by hand. If you want to draw it by hand, draw any breakline by hand, you should do this. Because breakline is not just for sake of generating something at the top of a levee. Or you might say, I'm really curious about this domain. It's really there is a kind of a building here that I want to generate a breakline as a perimeter of that building. That means I will show you as an example here. That along that building you want to produce a higher resolution than the surrounding resolution. That means you need to define a breakline around that and generate steps of resolutions. So in order to generate a breakline by hand, go to the geometric data editor, and you will see an option here that says add 2D area breaklines. So if you click on that, the mouse cursor will look like a pen. And then once you draw something like, I don't know, like this here, it should not be a closed polygon, but I did it on purpose. When you double click, once you're done, when you double click, it will ask you for a name. Just specify a name, say breakline draft. Once you did that, click OK. So nothing's happened yet because when you do the computation and find the mesh grids and recompute the mesh grids, the whole orientations and the whole association will be different at the end. But this is something just graphically shown here that is a breakline. If you click on that breakline, it will be highlighted like this, or any other breaklines that you have here. They will be highlighted like this. So you have these options. You can edit breakline data. You can edit breakline cell spacing, and also enforce a breakline in 2D flow area. So I click on this. That will give you information about the XY coordinates of that breakline. The numbers, the coordinates are based on, I think, these are the UTM types of coordinates. And these are the other breaklines that we have in our domain. Back to that, if you click on breakline line spacing, that's what I explained it earlier, that how you can specify what are the minimum and maximum grid cell size along the breakline and a little away from the breakline. Just I will jump to that in next pages, but let me give you a snapshot view of what I'm trying to say. So compare these two together. Can you check this out? So the lower breakline does not have a really fine resolution of grid cell size, but the upper one has minimum maximum specification of grid size. That means here you have finer resolution cells and you have coarser resolution cells, and there's a smooth transition from finer to coarser because as you see, I showed on the board that a levee, let's have it here. The levee have an abrupt change of elevation here, so that means it's better to have a finer resolution here, maybe even this, and a little bit coarser resolution, and then stick to the original resolution. So this is how you can define.
What is the width? Just understand question. How many? What is the width of that? 2D flow area? 2D flow area. 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 2D flow area.
okay. The minimum, so you can specify just two, that's levy. You can specify two limits here. Just this is the minimum, this is the maximum, and then you will be. So you have up to here. But this is the default version. You can even go further and manipulate that. You can add cell points here, multiple cell points, and just play with the centroid of those cell points to adjust them, and you can even have multiple or more than 2 or 3 cells along a breakline. But as a default, you can add 2 cells along the breakline. One is minimum and one is the maximum, and then within those you can add manually multiple.
So just basically 2 cells, for the
Yes.
default is 2 cells.
Yes.
Okay.
Then you can add it manually how many cells you want.
So what about if, like, I'm assuming it's one computational cell, like not the one that the last computational cell, like the one that generated by default, like rectangular cell. So that break line, so can cover more than one computation big rectangular cell, or it can have
Just 2. But then you can add, based on adding centroids or based on adding cell points, you can exactly adding more cells, and then you can adjust those cells to be aligned with whatever object you
But
want.
think about, you have a break line here, and you have a computational cell, like the by default computational
Yes.
cell like that, okay? The first one, and the next one is like that. So how far you go from that break line? Just a small.
You define it. You define it by the cell
So I
size.
can go 2 computational
Yes,
cells.
yes.
Okay.
You can define it. If your computational largest computational cell is 50 by 50, the minimum can start with 10 and the maximum can be 25. That means you have 50 by 50, and then you have 25 by 25, and then you have 5 by 5, and that's supposed to be your break line, and that is this. Okay. But this is not the terrain. This is mesh.
Yes, understood.
You should be careful about that. Mesh can be different in cell size. So this is the break line. This is the minimum, and this is the maximum, and this is the regular cell size of mesh, not terrain.
Yes,
Mesh.
Think when we can break for this, people can take their notes.
Okay.
No, you can.
Oh, okay.
So I'm about to end this section. I mean, it's not really far away from us. So I was trying to show you that how you can add manually a break line, not just for sake of showing where is the head of or crest of a levee, but around as a perimeter around a building or obstruction that you want to capture hydraulics around that. And let me do that for you again. That will also answer his question. Getting back to that breakline. Where did I put that? There we go. So if I go to this, first I want to enforce it to the mesh grid because it sounds like it's not enforced. So go to the edit, not edit, just to the view because I clicked on the pan. So it's now turned off. So it's the cursor is like this. Now you can select any object here. So select this and select on this option, enforce break line in 2D flow area. When I do that, see, it's changed.
So why is it inactive in my case?
What's that?
It's inactive when you go from should I select
Because you. Oh, why did you put that outside? It needs to be inside the 2D. Yeah.
Can you set the elevation at this point? If it's a levee, for example?
Yeah, yeah. That's what I'm saying. If you import it as a shapefile and also you are drawing it, you can specify elevation for that. But there are two ways to add levies. One is the tricky way, and the other one is the professional way. The professional way is to go like those people who are trying to add levies and other hydraulic structure in HEC RAS. You should go and define these types of structures. The thing that I would suggest you to do, I did not put that in my lecture, but I will let you know how to do that. It's a really tricky way. You remember how did we generate a river channel? We had the geometric editor data from river channel, and then we turned it into raster. So you can invert the channel and turn it like a levee. You see what I'm saying? So I'm going to say how we can generate a levee, but not as a geometric data, but as a DEM layer. So suppose that we had that channel as geometric data, and then we turn it into a terrain layer. So if we invert the channel cross-section, it would look like this. So suppose that you have information about the levee as the crest height and the lateral slope, then you can generate a cross-section as an inverted, like an inverted channel, and then turn it into like a layer, raster layer, and as we can diffuse different layers together to generate a combined layer, just diffuse it to what we had. This is what I did for my last presentation yesterday, to add levee and cross-sectional geometry to my data, my original VM.
So if I drill outside the mesh area, wouldn't it have any?
It will give you error because it must be inside the mesh area.
Yes.
Yeah. So see the default mesh resolution along the break line is like this. So I want to change it into something else. Go just click on that. It will be highlighted in purple, and select the edit breakline cell spacing option. So it asks you for minimum and maximum space. So would give it what should I give it? I would give it 50 as minimum and 100 as maximum, because my mesh grid cell here is 200 by 200 feet. So if I click OK, nothing's happened because I need to enforce it again. Click on enforce, then you have something like that. Okay, something's good happened here. Actually, it's not good, but it's good to happen. I will let you know what to do with this. As I said, why is this? HEC RAS is limited to 9-side polygon. So we have maybe larger than 8-side polygon, hexagonal. So we have larger than 8-side here. And that would show up as an error by highlighting the centroid as a red circle. So you need to change it into something else in order to be limited to those restrictions. So in order to do that, you need to add a central point, to add a new cell here. In order to do that, go to the edit, if you have the same problem, and click on add points. If I click on add points, then the mouse cursor will look like this, a plus and a circle, or solid circle. I click on this, see? So it now, not hexagonal, pentagonal. And then when you go back to the edit and turn off the add points, it will gone. It will be gone.
What's the purpose of this step?
The last one that I explained. Remember there was a red dot here?
Yeah, I have a red dot.
You have a red dot, good.
I have
So actually it's not good, but it's good to have.
two red dots.
So, but you better not to cross the breakline. That's what I suggest.
Okay.
So suppose that you have resolved that. So
on this, this will gone. So you better to add something much more solid as a background layer to be visible. But let me suggest you something. So I may say, I wonder if you can change the, or maybe it's just in RAS mapper, but I hope that you can change the thickness of these layers. But anyhow, that's not going to change it.
Zoom in there.
Yes.
But how do you change that?
Yes, I will
I know, it doesn't sound like, yeah, it's a weird
Some
name.
come to
But,
Avenue.
it's downtown on University.
Normally they don't do that.
I think you have the only option is vegetarian.
No, there's another.
And it's
there's
really good
restaurant.
actually. Like I was so surprised. Like last week. They call it like global street food.
Yeah.
So they have like they have like tacos and shawarma and different kinds of like sandwiches and salad. And, like, yeah, it's really nice stuff. well, so it has to be affiliated. Yeah. But yeah, almost all of them are. And like interact matches. Yeah. It's like, I mean, probably 90%. Actually, it wasn't as initially. The first year I feel like it's totally nice.
This,
Just look at how each combination
Mhm.
So this is the mesh that we're looking at. This one is
let's continue. Is it still recording? I guess we didn't. Yeah. Yeah, we didn't shut it.
Yeah, everything. So let's continue. Up to this point, we learned how to add break lines to our geometric data editor by means of shapefiles and also by drawing by hand. And now, let's have a view of how a grid cell would look like, or how a mesh grid would look like, and what are the components of a mesh grid in HEC RAS 2D. So mesh grid comprises cell center, cell face, and cell face point. You can see it on the board. And after all break lines have been added, the computational mesh can be generated afterward. And the user can also add additional break lines after the mesh has been generated and recomputed, actually. And they can be refined by the user by adding multiple break lines inside the mesh grid to just change the alignments of those orthogonal meshes to something hexagonal or whatever. And the 2D flow area defines the boundary for which 2D computation will occur. So cell center is where the water surface elevation is computed for the cell, and the cell center does not necessarily correspond to the exact cell centroid. It's not actually the geometric centroid. It's somewhere that you can easily move the location by the cursor. And cell face cell faces are generally straight lined. They cannot be so a cell face cannot be something like this. So if you have a point here and point here and point here, so this is the grid cell. So and if you have something here, that would be pentagonal, sorry. And but if cell face cannot be like that, so it must be a straight line. Just for cases that we have, the cell faces cannot be like this inside the 2D flow area. But for the boundaries, as you can see here, for the boundaries, it can be not straight. It can be something like this. It can break while going from one point to the other point. Just for the boundary.
So if cell center is not the centroid, then what it is? Is the random point the cell centroid?
When you develop this mathematically, that would be a centroid. But that means you can also change the location of that, and you can turn it into not a centroid. As a default, as it will be generated by HEC RAS 2D, it will be a centroid. But that means when you can adjust the location of that from this default location. Default location is a centroid, but user can adjust its location because that would capture some information. And below that, if you have a terrain that will have some information at this point, then this point you should replace it to this place. Just extract that type of information. But it's a really tedious job. I think if you have finer resolution, it's not necessary to worry about the location of the cell phone. But if you have a coarser resolution, you should be careful because the place that centroid set is important sometimes.
So it determines what does it mean?
It extract the elevation. So say whatever you have below as land cover layer. So where this guy sits,
would extract the information of that land cover. So if that land cover layer is really finer resolution than what you have at the grid cell here, and you have, say, water, you have jungle, you have something else, where it sits, it will extract that land cover.
Something about the control, also the depth of
And also the depth of the, but because the depth is a little bit trickier because the depth also depends on what you have at the site.
Any more question on this page? So now we reached to this point that we are going to generate mesh grids. Originally we had talked about this, how to generate a polygon where we should generate the mesh grids. But I had made that before. That's why prior to this moment, you had seen these types of mesh grids. But suppose that we are at this level that we are not having these mesh grids. So suppose we are talking about this area, and we want to generate similar to those mesh grids, a mesh grid network for this blank area. So in order to do that, you should go to this option that says 2D flow area, right at the left bar. Click on that. That window will pop up. So here you have option to select. So I have my original geometry that is this, that I had manipulated earlier. Sorry. So this one that is now purplish is the original geometry. Its name is geometry 2D flow area underscore test. The one that I'm going to generate mesh grid inside is this guy. That is geometry 2D flow area, or AR, that I had generated. That is blank. So back to this. I need to select which polygon I'm going to generate mesh grid inside of it. So this is the one. And here are the options. So let's get back to this again. So I click on this option, and this is how it would look as we had that side. So by clicking on this button,
this window will pop up. Here you will specify the computation point spacing in delta x and delta y, as delta x and delta y in x and y direction. So based on the unit that you specified in the beginning, if it's US customer unit, it's now 250 feet. And if something is wrong in your map and your data set, you can also shift those a little bit up and down, but it's not the case here. And it really would be the case in other projects. So as you added those numbers, just click on generate points in 2D flow area.
And this is the spacing between the computational grid cell centers. Actually, this is the distance
Between these centers.
So let's get back to HEC RAS. So if I go here and select that geometry and say 250, 200, let's say 200. I would do 200. Just I want to show you the difference between this and the other already made grid cell, mesh grid. So the next step is, once you do that, the next step is to enforce selected brick line and internal connection to the system. This will create cells that are aligned with the brick lines. We are in the same page again. I mean, we are not going.
But wait, so I don't see the spacing itself. So pretty for
Oh, okay. Did you generate in the polygon?
yes.
This is your work. Okay, so now you need to go here and then specify.
Sorry, thanks. 200, right?
I specified 200. You just. So this will create cells that are aligned with break lines. If you already put the break line inside that domain, that would find out those break lines here. I call one upper, the other one middle, the other one lower. And when you select them all and put them on the other side and enforce them by clicking OK, it would recognize that, hey, you are going to align or change the direction or orientation of those grid cells with respect to those break lines. And you can enter, as we did, different cell spacing as minimum maximum cell spacing along each break line here. So let's do that on my side. Okay. So I say enforce. I also would add my already made break line draft too. So, and then click OK. Now, what's next step? Now, if you click on the last button, view edit computation points, the user, you can view those points or those centroids, I can say right now, the coordinates of those points. And how many cells do you have on your side? So let's see how many I have on my side. So that generated 73,000 cells based on what I specified as the resolution of those cells. And if I want to view those, just the coordinates, it's not there yet, but it gives me some information about the coordinates. So these are the coordinates of the centroid. So we have 73,971, and if you go to the bottom, the last coordinate is also have the same number, 73,971. So let's check out the other options here. We have edit land cover to Manning's n. We are not there yet because we don't need to select that button yet because we did not define any land cover, or we did not add any land cover layer yet. So the thing that you should do is to just click on the force mesh recomputation, or say just OK, not clicking on that, just click on OK, and you have this. See? This is how it would look like on my side. And the original mesh that I had was 250 by 250. The one that I created a while ago is 200. So you can see the difference here. See? I had another layer at the top of the already made layer, so you can see there's no match between them because the resolution are different. But anyhow, this is how you can add a mesh grid to your inside of your 2D flow area. But we're not done yet with 2D flow area. We will be back to the option of 2D flow area after we added land cover layer to our model. Do you have any question on that? Yes.
Okay, because that's, it sounds like there's something wrong with this British, so you can go and zoom in to see what it looks like. And there's also, there should not be any mesh here, but did you generate a mesh? but where were you? Where were you? Where was the moment that you found yourself lost? Did you generate that mesh tree, or did you, or why did I thought maybe you had generated that polygon?
Yeah, me too. It's hard to edit.
Where did you say that?
Yeah. I don't know. Well, don't mess with it. It's not advice.
You didn't generate it, I just have them. I mean,
Yeah. But
oh, save, oh no.
Huh? I got one red one and I fixed it. Oh my god.
Just why don't you have it? Oh, because you're open one.
Oh, it's in this thing, right?
don't worry about these odd shapes. In order to resolve this, we're not there yet, but you can go here. Yeah, and you can just say force mesh. But it's supposed to give you some different, maybe you need to add manually okay.
So we generated our cells, and also we enforced those break lines to our cells to just align the pattern of those cells. This is a good option here to say once we have an obstruction and we want to find out what is the flow pattern around that obstruction, you can add a break line here and just play with the size of the cells to make it from low up to high resolution of the cell to capture some hydraulic step. And the computational cell will control the movement of water through the 2D flow area. The computational cell faces control the flow movement from cell to cell, and once the one water surface elevation is calculated for each grid cell. That means we do not have multiple water surface elevation in an individual grid cell. And within HEC RAS, the underlying terrain and the computational mesh are pre-processed in order to develop detailed elevation volume relationships. That's important because when it develops those elevation volume, then anytime it wants to compute hydraulics, it will go back to that rating curve, something like a rating curve, and then interpolate based on that rating curve and map a layer. And where the water surface slope is flat and not changing rapidly, somewhat like in floodplains or flatlands, you'd better to add larger grid cell or coarser resolution grid cell. But for those like this place, where you have a levee, or this place where you have obstruction, you'd better to use finer resolution to capture those rapid changes. Otherwise, it will not capture them. Yes. Yeah, I just highlighted that point that you can.
The break line, basically, if I understand, is only to adjust the grid size around the
Exactly. It's not a way that. It's not a outline of. It's an outline of hydraulic infrastructure, but it's not.
If you have the
Yes.
terrain,
Yeah.
the DM.
You cannot add anything more, and you cannot add geometry to them. It's just for changing the alignment of grid cells.
I think it's more important because the momentum, the way momentum transfer, because it's having a slope, so there is no cell area, better efficient you can transfer momentum.
So this is what I also had done earlier to show you. Once you have made a grid cell, you can adjust the cell resolution along that grid cell by clicking on that break line and choose the edit break line cell spacing. And that will pop up a window where you can add minimum and maximum spacing of cells along the break lines. And the mean cell size gets used right along the break line, then it transition out the maximum cell size, as I mentioned. But you can, this is just two cell transition. You can go back to the geometric editor and add points along that, not along, but nearby those break lines to add more detail or add more resolution if you want. So I may zoom in to show you. I think I did that earlier on my side to show you what I meant. So at the top, you had a coarse resolution along the break line, but once you change the resolution of these adjacent cells, you would end up to something like this. See? So then it is a finer resolution. That's what I was looking for.
So how do you ensure that this transition gradual? How do you ensure the cell size transition gradually?
So as you did this,
I wonder if there is that option down here. No. So let me go back to HEC RAS again. So sorry, I need to first remove this new. So when I click on that and change the spacing, it's up to you. Say if the resolution of these grid cells are 250, you can start the minimum grid cell to be 50 and the maximum be 100. And when you enforce this, it would look like this. And the good thing is that they are uniform based on that grid cell. But the thing that I was talking about is that you can say, okay, I don't really like to have this pattern here. I may want to add another point just for sake of being more in detail. And then get back to the edit and see. So automatically it will generate this uniform shape based on what you specified as minimum maximum, but you can edit it manually. So zoom out. Okay. So that's what I did for some of you, that you have some errors or some highlighted points at some region that shows that there is something wrong here. Either the number of, for most of you, the number of sides of the polygons were larger than 9. So that caused a problem that you need to add points to turn them into less than 9-sided polygons, or you have something weird like this. I have no description for that, but you should either add a point or remove one of those points. And we did that. So, and this is how we modified or edited those points to be adjusted to our restriction or standards. And this is another option. Just look at the right figure. Say you have a river, that's the river channel, where you have right bank and left bank, and you have the center line, okay? And you added those parallel break lines to specify these lines. And if the break lines are so close enough to each other to generate some confliction, at some point you may have these conditions. Say, along one center line, you have a side that would look like this. Along the center line, you have a cell would look like that would look like this, And on the other side, you have something like this. Okay? That's what I had mentioned a while ago, that within a grid cell or mesh grid, one side may not have a break. And that causes a break here in one side, because these are cell points or side points, I can say. But within between two cell points, the line that is connecting them inside a mesh grid cannot be breaked like this or like this. So it should become like this. Whatever you have on the other side must be parallel with the other side. So that's the correct configuration, not this one. But when you have two parallel break lines so close to each other, that might happen. The left side might happen. But by means of adding and deleting some cell points, you can adjust it to this side. It rarely happens. It only happens when you have two break lines so close to each other and the cell resolution are so coarse. So that will happen in that case. So you always need to zoom in and resolve this issue. And I should note that no cell points will highlight as red at this condition, at this wrong condition. But at the end of the day, when you compute it or run your model, you should not trust your answers.
So how do you, so I have to make sure we have to look on the grid details so that
Yes. Yes.
you can see it remote view. You have to go
Yeah. Yeah. After you generated the mesh grid, you should go back and check out each part of the mesh grid. Yeah. But I said it only happens when you have two parallel break lines so close and your coarser resolution cells are within those break lines, two break lines, and that might happen at those cases. So now we want to create spatially varied Manning roughness layer. We want to deal with roughness layers. So a spatially varied land cover data set can be created in RAS mapper also, and then associated with a specific geometry data set. There are two types of land cover layer that you can deal with in HEC RAS 2D. One is user-defined polygons, as you can see on the right side, and the other one is a gridded land cover data set. I wonder if I could find that gentleman in the audience. But somebody asked me yesterday that what if you have a what if you have something like this case, that you have a grid cell that does have one land cover from coming from a particular type like water, and the other one coming from a land. What you should deal with, how you can deal with. I answered them that you can also add a polygon and specify Manning's roughness to that polygon to resolve those issues where you have a confliction between land cover resolution and mesh grid resolution. So you can adjust it by yourself by adding a polygon as a land cover. That must be a shapefile. And RAS mapper allows the user to use multiple land use data file and types. That means in some regions you have a data from one source, and in other parts of a region you have land cover data from another source. You can, as we did for the terrain model, that we have multiple terrain model and we stitch them together, you can also do the same thing for the land cover, and you can make a unified land cover and apply it in the model. And at the end, whatever you develop would be in terms of a GeoTIFF file, if it's defined in RAS mapper. And for each grid cell, you can define, for each land cover type, you can define Manning's roughness. So this is how you should do that. So going back to the RAS mapper, so now I'm in the RAS mapper. So going back to the RAS mapper, you should go back, you should click on the map layers. Right click on that and see you have something called add new land cover layer. When you click on that, that will pop up. Suppose that you have NLCD National Land Cover Dataset 2001 raster layer that is 30 by 30 meter resolution layer, and you are going to add it as a land cover layer. So when you click on that cross button, you have maybe this window to pop up, and go to the land cover folder, and you have this land cover with no extension. Yes, just click on that and open it. So when you open that, the thing that you would have is the name of that file here, the projection that says same as the project, we had defined it earlier, the cell size of that is 100 feet, that is about 30 meters, and nothing else that is important here. And you have some other windows, sub-windows that you need to recognize what are these elements. So these numbers, because the original land cover is coming from National Land Cover Dataset, the National Land Cover Dataset is this. If I zoom in, so those numbers that you saw are those numbers. I mean, 11 means water, 21 means open space developed, 22 means low intensity developed. So for each of those layers, you can assign a Manning roughness. So each cell has this meaning. So let me zoom out. So you need to, you can also name them. So the 9 mint, what? The 9 mint, oh, I didn't have it? That's interesting. Why? Oh, maybe, okay. That's good to know. Okay, so I forgot to say. So in here, you have a radio button called originally as custom. So click on that, and then you have an option called NLCD 2011. Click on that, and then some of these values will be changed, but I wonder why. They're supposed to be. Let me just do this again. I mean, something is wrong. Just delete it. Maybe I should have used land use instead of land cover. Oh no, it's not working. Oh no, I mean, mine is frozen. Okay, but these numbers are not those that I was looking for. That's odd. Maybe I need to go back to this page, land cover, land use. Because I think, let me go back to here. Okay, so this is how you can also adjust your data with those numbers, or say adjust your land cover with those numbers. So 2, 3, 4 up to 16 means those names. So you can also adjust that with that. I don't know why it's not showing those special numbers associated with each land cover. It's odd, right? Yeah. So the only thing that I can suggest you to do is to keep them as it is. Do not change anything until you should have done something, because or maybe I need to click. Oh no, it's not that. It's not that. I think this is what we have. I think we need to find out the meaning of each of those elements. Let's go back to. So if I, but that's really complicated. So if I go back here and just get some information about either of those elements. So here 9 means deciduous forest. 4 means open water, and 3 means mixed forest. So you can also apply these IDs along with those numbers and try to adjust this land cover layer to that. So these numbers are corresponding to those names. So you can either add those names, say 9B forest, or 15. You should go back and see which one is which one. But I'm wondering why it's like that, because when I imported my own land cover, NLCD 2011 land cover data set, those numbers are exactly similar to those IDs that I had shown you. But just for the time being, I think you should be okay if you just keep it as it is. But on the other block, you need to add the Manning's roughness associated with each layer, or corresponding to each layer. So suppose if 1 corresponds to water, open water, so you should add a Manning roughness of open water, say 0.035 or 0.04. Or if 12 means developed area or densely urban zone, you should add a higher Manning roughness, say 0.1 or 0.15. And you can go ahead and fill out those empty cells based on your need. Forest can be 7.5. And once you had done this, you can assign a cell size value for the final geotiff image. And because originally you assigned it as a US customer unit, it shows as a feet. So you can say I want to have my end result to be like 220 by 20 feet. And also that final hierarchical data can be data file can be named as you want and put it in wherever you want as a folder that specifies those land cover layers. So I can say my land cover and so forth. And if you click on create, I would not do that right now because I did not fill them up all. But if you click on create, the same window will come up and shows that it is loading, it is generating those layers. And at the end, what you will have is something like what we have here. as this layer, this colorful layer. That sits at the top of our background image. So if I just remove that background image for a moment, so it would be like this. So each color has its own meaning and has its own Manning's roughness. In order to find out what color means what and what's their Manning's roughness, associated Manning's roughness values, in a map layer, sublayer, just click on the land cover and go and right click on it. And in first option you have land cover colors. Just go to that. So you have these explanations for each color and their names and their Manning's roughness. You cannot change anything here. It's already submitted, and it's just for sake of showing you what color means what. But you can change the color. For example, cultivated crop can be shown as orange, say. And also you can change the transparency of the layer from solid to something transparent. So it will be like this. If you have something below this layer, it will be shown better. So I just explained all these. Now here the times for associating already made layers. We have terrain layer, we have land cover layer. So we are going to associate these already made layer to our geometry polygon that or the mesh grid that we already made in geometric editor. So in order to associate them to that particular geometric file, you should inside a RAS mapper, you should right click on the geometry in RAS mapper and click on the, as we did earlier, I showed you, manage geometry associations. When you click on that, this window will pop up. So these radio buttons contain, if you have multiple land cover layer, multiple terrain layer, you are associating those land cover and terrain model to these RAS geometry layers that you had generated in geometric editor. Then once you did that, when you compute any geometric when you compute all those geometric steps, you should know that the HEC RAS is extracting information from that particular land cover and that particular terrain. And maybe prior to doing this association, you may have some problems, like some of the mesh grids are beyond the land cover layer. Say you have something, suppose that is your geometric area. That is a mesh grid. And say that is the land cover raster. Okay? So you missed some places like here. Okay? But the other layers like the terrain model can just have this place. But the land cover layer that you had does not contain this particular point. So what should we do with this particular point? What is the Manning's roughness to be assigned to this point. So in order to do that, you need to define a default Manning roughness for those regions for which there is no land cover layer, or for at this zone no data is provided for the land cover layer. So in order to do that, you need to define the base Manning roughness or default Manning roughness to be assigned to those places where there is no land cover. So in order to do that, in the geometric data window here, so oops, you have in a geometric data window, go to tables. In the last option is Manning's N by land cover. Just click on that. So that will come up. Here I had filled them out earlier, but maybe on your side, this base Manning's roughness are blank and are empty. So that means if you fill them out for those places for which there is no land cover layer below that, HEC RAS would assign those particular values, that is 0.40 or something, to that. So we can take the average of all the Manning's roughness that you have, just in case that you don't know about what is going on here in real world. But you can assign this as a default Manning's roughness. And you can only edit these values on base Manning's N column, and you cannot assign any new value to this side. Okay, so also, one of the other advantages of the HEC RAS 2D in specifying a land cover is that, as I said here, suppose that the land cover layer, the raster land cover layer, does not contain any information for this particular place. You have either the option to just define a default value for land cover for those non-given land cover places, or you can just generate a polygon for that particular location, or multiple polygon inside this location, and assign a Manning roughness value for those particular polygons. And those particular polygons will sit below that mesh grid, and that mesh grid would recognize those polygons prior to the default land cover layer. So that is really good for those places where you don't have enough information about the land cover, or you have land cover but you have a channel in the middle. You have the river channel in the middle, and you want to specify a particular Manning's roughness for that area, and then you can define a polygon aligned over this area, and for that polygon you can assign a Manning's roughness. That's what you are seeing here. So these are national land cover data set for that region. If you zoom in further, you can see that it is not well aligned with true image or true color image. Somewhere that you have a red grid cell, you might find that, hey, this is not a developed area. This is exactly water. In order to resolve this, you can define your own polygon at the top of a land cover layer and say, okay, whatever I have here, I want to assign or regard it as water, or I want to regard it as something else, and then assign a particular Manning's roughness value for that. What's that? Okay.
Yeah, once you have those multiple layers of manuals, how do you order them in order of importance?
So for land covers, if you have rasters and you want to combine them, the one that you want to put at the top of the other one when there are some confliction, it depends on you. But for this particular thing that you have defined a polygon, it is already there. The raster would regard or give priority to polygon than other rasters.
So are you going to generate this polygon in the geometric editor or in the RAS mapper?
Okay. Okay. I will explain it later. I'm about to explain it. Yeah. In order to do that, you should define it in RAS mapper. If I go to the RAS mapper and suppose that I'm going to say this is the true color, and this is the river. This is the river channel. So if I add the land cover layer to that, you see there is a discrepancy, or there is no match, a well match due to the resolution between the land cover and that river. Okay, so in order to resolve this issue, you can add that polygon and assign a value to that polygon as Manning's roughness. In order to do that, going back to the geometric data editor, satellite imagery, and let me just remove the color of that polygon. Okay. So if I zoom in again, okay, so in order to add, you should go to this option, 2D area man region. When you click on that, the cursor would look like a pen, and then you say, okay, start from here, just draw a polygon, and then I think that's enough for here. And when you reach the starting point, just double click on that, name it something, I don't know, my land cover. And when you do that, it will look like this. And when you click on that, you can either edit it by means of changing the X and Y, and also you can also import a polygon from GIS or of whatever data you have, and you can edit Manning values for that. So when you click on this, you see you have a new column here called my land cover, but it doesn't matter if you have multiple rows. Whatever you have here must be unique. So that means that land cover, that polygon would be assigned by this particular Manning roughness.
So what does the rest of the you don't need to pick
This is the original assigned Manning roughness for these layers that are raster cells.
So my land cover you just assign new data for each column?
Yes.
Each row?
You know what? Because you had something like this. If I add land cover, you see that that polygon would pass through different cells. And back to that table, where are we? Okay. back to that table, you see that when it passes through, for example, the purple cell, and it have intersection with the green cell and the blue cell, those purple, green, and blue have their own meaning and have their own row. And then when you assign something like 0.35, when it's passing through this, it would be 0.35. But when I say I want to have them all as one unique magnitude n, it doesn't matter when it passes through either of those.
So I can have different data, like two different.
Yeah. Yes.
But here our objective is to put one value, unique value. So just put all the columns.
Yeah.
Give the same number.
Same number.
Can I just because
I think sometimes great just for the people just go back to cost so many
They're there and they're associated. I mean, the thing here is that you may
Oh, sorry.
Yeah, but I wonder why you don't have the other definition for the
It's an example. I don't know, so
because
that's
it's
why.
not, I mean, you should have adding a different layer,
So, yeah, so if I add a new one,
Yes. The thing is, the thing is that's confusing here is that these numbers are not relevant to those legends that I showed you. The only thing that you can adjust them is to go back to my lecture and this window will give you information on which room we're in.
so this is
So I think these numbers are going to be somewhat
so it has two different.
Yes, these are two different nomenclature. So NLCD is National Land Cover Data Set.
Yeah.
It says 11 means something, 12 means one.
Yeah, I know, but I mean, I don't know what it is from. This is
I extracted from the user manual of the aircraft studio.
so it will fit those kind of
Yeah,
database.
you can fit it in National Land Cover and then anything that you should be sure
Well,
about
so
is
that's
with
this,
the meaning of those IDs that were numbers. So 9 would mean something like this, 1 would mean
yeah, so
the
it should be the one.
So I know, so this number is for both of those two database or just
yes,
the one?
yes.
Okay.
Just for the National Land Cover.
Okay.
But I thought I didn't do anything with it. When I filled the data, I don't know why.
What's the next?
But I didn't put many
You
dictionaries.
should have. You should have.
But for some reason, I didn't have them.
Because that's why I'm saying if you go back to those land covers have their own manual. So
It's already in, right?
it's not there. You should add it. You should add those manual roughness values for each layer.
She didn't.
I didn't add it, but she has a lot of things.
Oh, you have it. Okay, because some people, I don't know why, I had that layer prior, I just made those layers just for sake of this lecture. That's why you made those numbers for that particular raster file. But the thing that I'm saying is for those people who are trying to do this in scratch, from
Yeah,
scratch.
you should put it.
Yeah,
But for this class exercise, she
Yeah.
should have a file that she could just
Yeah,
use directly.
I wonder why you could not access that. I'm sorry. You have it here. I mean, you have it as this. Oh, what's
So let's continue. So do you have any specific question on associating roughness or generating Manning's land cover? Or so if you're good, we can continue. By the way, I put a lot of detail in these pages, so if you just read those bullet points, you may find a lot of information if you have questions on that. So, and this is how you can create a hydraulic property table for 2D cell and cell faces. Once a terrain model is created and optionally a Manning's N value by land cover table is associated to, the following steps are required to create a hydraulic property tables for the 2D cell and cell faces. So you should associate first a terrain layer that you had generated with a geometry file. So in order to do that, you should just, in RAS Mapper, right-click on the geometry sublayer and click on the Manage Geometry Association. That window at the bottom left will pop up. And then for how many geometry layer that you have corresponding terrain. You can associate corresponding terrain and land cover based on how many you have. For most of you, you have only 2 or at most 1 geometry row. But here I just took that snapshot from a giant or larger project. Just for sake of showing you how it would look like when you have multiple geometries. And once you had made that step, you can say 2D cell and cell faces geometric preprocessor can be used to show you what are the geometrical shape of each side of a cell. So suppose you are in the RAS mapper, and when you click on one of those layers, say this guy, Bald Eagle Creek Geom Test 2, then the mouse cursor is sensitive to each of those sides and cells. And when you navigate through those cells, either of those sides or cells overall will be highlighted purplish. And for example, I stop at this side, and the cell side will look like this color, and then I right-click on over that cell size. This window will pop up. You have these options here just for that cell size, but it will also capture some other information from the surrounding cell size. So it can give you the option to, if you had run your unsteady flow analysis, you can develop a time series plot of flow that is passing through that site. We had not done that yet, so just skip that option. You can find out an ID. So each of those cell sites and cell centers and overall cells has their own ID. And if you are looking for a particular cell, it's so hard to find out because there are so many cells. But if you know one of those cells, you can go and say and give it the ID of that cell, and it will find it of that cell in that domain for you. But the thing that we are going to see here is to find out for that cell what are the, for example, volume versus elevation, area versus elevation, and weathered perimeter versus elevation, Manning's roughness versus elevation, and also a profile across that cell or across that cross section. So when, for example, you click on that option called vetted perimeter elevation, that would bring up this window. So this is for this particular cell that has the ID of 689. So that says the vetted perimeter have these types of relationship with the water surface. Have this relationship between the bed elevation. So this is the relationship between the vetted perimeter and the bed elevation. And you can also see the other cell faces that you can navigate through and find out where are they. And you can turn it from a graphic image into a table. Then you can extract those information and go back to somewhere else like a spreadsheet and work on them there. So the next option is, for example, volume versus elevation for that particular grid cell. That would look like this. Or a profile across that cross section. That would look like this. HEC RAS would use all these information itself to produce the flood mapping. Besides that, it shows you some information about that cross section. But it's highly important for sake of producing those flood maps based on these cell by cell and side by side information. And this is another view of that information in terms of a tabulated data, not just a profile image. Sure.
What are you trying to do? Cover this table. What I'm doing here?
Oh,
Okay.
it won't.
I think you should better to go back to here. Or
Okay, I think
I wasn't wrong. I wasn't even wrong. I wasn't wrong.
I have like an internal calculator.
I wonder why highlighted the whole thing.
Also, it does.
Oh, got it.
Did you generate it? Oh, okay. Did you generate the?
I don't like it.
So this is my mesh. But it's not there.
Yeah.
It's on this guy. So when you turn on this guy and you click on this one and zoom in a little bit. Then you can see if you can see then you have this like yeah, and then you click right click on this, you have these options. You can say but when you click on that it will just compute something. Just extract information here. Because this guy did not have 2D flow area. I just go to that layer that does have 2D flow area, those mesh grid that we generated, and that is containing that mesh grid.
Where did this come from?
So one does have that 1D geometric data, the other one does not have it. When the one that does have 1D geometric data does not have a 2D flow area. That's why you have no 2D flow layer in that layer. Someone has questions?
Yeah. Whatever from there.
Oh. But you have those information. What is your question?
Sure, you.
Oh.
So do you have any other questions on this page? Okay.
Because I think you're watching it through layer, this is solid layer, it's not meshly, and because it's in this map layer. So the thing that I'm looking for is to bring in that 2D flow area. Oh, because you have this problem. You should resolve the issue.
So you have to upscale
Yes.
that one.
Yes, for you. Can you please go back to the geometry episode? Do you have any problem to zoom out a little bit? Okay. Please resolve these red dots first, and then go back to the RAS mapper. You should please zoom in. Yes, I can find that. So, add more points nearby those red dots. Don't worry, it's good. I think that you know what I can see. You should resolve these points first. You should add somewhat point or remove those, but I would say just add. Yeah, just random. Give me back. Oh, yeah. Are you resuming that? Just try to remove all those red dots and then go back to RAS mapper and then it will be fine. Okay, I think I have the same problem on the other side. So you should resolve any of those problems if you go back to I know that there are some problems like this. So try to just remove all those red dots by adding more points or removing some points to just resolve this issue, and then save it and then go back to Rasterizing. So, suppose that you had done everything okay, and now you want to let the HEC RAS to extract all those information of terrain, of land cover, by means of all those cell sites and cell centers. In order to do that, for that geometric data, for example, we are talking about here, this one, for which we have 2D flow area. Go to that 2D flow area and right-click on that, and just you can see that compute 2D flow area hydraulics table. Just click on that. Once you do that, these types of pop-up windows will be shown that are being executed and loaded, and that shows that there are some processes being made within HEC RAS to extract information from the below layers by means of cell faces, cell centers, and hydraulics will be computed at those centers and along those or across those sites. That will be called pre-processing procedure. Prior to running a hydraulic flow simulation, you can do this, but if you forgot to do that, HEC RAS itself, while you're simulating this, will do this automatically. It would recognize that the user forgot to do that, and it will do that. But it's better to recompute everything once you had some modification. Then it will secure you from any errors in the future. So if you're good, could you resolve that issue if some of you have those problems for geometries? You didn't? Could you remove all those red dots? Okay. But can we go further, or you want to help? You okay. So the next step is how to assign an external 2D flow boundary condition. So we have upstream boundary condition, we have downstream boundary condition. At some cases we have some locations where we have hydraulic infrastructure like dam, for which we want to assign a release time series or gate, opening gate or closing gate time series, where we have outflow or water storage, elevation, whatever. So you should define boundary conditions for this. So suppose that we had add a boundary condition line at the end or within the 2D flow area. These are the options that you can add to those boundary conditions. If there are external boundary conditions, say you're adding them at the end or at the beginning, not in the middle, these are the options that you can add. You can add flow hydrograph, you can add stage hydrograph, you can add just normal depths and rating curves, that means stage versus discharge, and even point values of precipitation. I never use that. I mean, I'm not. I have no information on that.
Wind.
Yeah.
Will you use wind?
No, you cannot use wind. It's not hydrologic. So maybe you can attach it to HEC HMS, but I never done that. And normal depth is always attached to the downstream boundary condition than upstream. Never. I never heard someone add a normal depth to the upstream boundary condition. But flow and stage hydrographs can be assigned to any side of the domain, regardless whether they're upstream or downstream. I mentioned these here, that the normal depths and rating curve boundary condition can only be used at the location where flow will leave the 2D flow area. And the flow and stage hydrograph boundary condition can be used for putting flow into or taking flow out of the 2D area. And for flow hydrograph, positive flow values will send flow into, and if you use a negative, it sends the flow out of. So you should be careful, for example, for conditions that you have an estuary where you have a tidal event at the downstream, and you have seizing of saline water inside the freshwater domain, and then you have saline water that are receding back into the ocean. When it's coming into the domain, it's
coming through an opposite direction of the freshwater inflow. So if you are assigning a flow hydrograph as a boundary condition for the saline water, and you want to show the intrusion of the saline water, you should assign a negative flow value for the hydrograph of the saline water. And for the precipitation, you can just add a point value, values at each point of the site, and just give it a maximum value of rainfall. That's nothing else that you can do. And so suppose this is our study domain. So we have a downstream location. So you can see this types of cross red, black line that is actually the boundary condition line. You have in the middle, along the dam outline, a middle boundary condition. And also at the downstream point, you have two. You can assign multiple, just 3, 2, or even just one boundary condition at each side of this place, as you wish. So in order to do that, oh, I had zoomed that on the other pages. So I meant this. So some places may have two separated boundary condition lines. And the thing that you should be careful about is that two boundary condition line cannot be overlapped. So they must be separated. Be careful on that. And also, suppose that might happen in some of the examples that you might work in the future, that you have a cell that would look like this, and another adjacent cell that would look like this, and another adjacent cell that would look like this. So for this cell, you have one boundary condition line, and for this cell, you have another boundary. For this side, you have another boundary condition line. So that looks okay, and this will not give you any error. But suppose that in one side of a cell, although they are not overlapped or touching each other, if it comes to this side and ends up to here, and you have two boundary line that would end at the same side of a cell, that would give you an error. So be careful on that.
So boundary line does not need to complete the cell face?
It should not be on the same face, no. For example, it's not happening here, but if that comes up to here, but it's not in that cell, it's okay. But when it's come to here and this guy also in the same face, that will give you an error.
So but my question is that does the boundary line should end at the end of the cell?
Not at the end of the cell, it can be in the middle of the
cell.
Yes, yes.
And how does the flow distribute it between two cells?
Between two cells, so it will, as you see, as I explained it, based on the resolution of the below train model, maybe maybe it's based on the way that HEC RAS would assign the end of that. I mean, you may not leave that end of that boundary condition line wherever you want. Maybe if you do this, HEC RAS would recognize if there is about 10 cells along this side, it will leave that to the last cell, or wherever the cell points are locating. It will end up that the boundary condition lines at the top of the center of that terrain cell. But you should be careful of that. I mean, either HEC RAS would raise red flag here that say there's something wrong here and you can easily find it out, or if you don't find it, there's always something wrong at the boundaries. You should go back to those and check it out. Check them out.
Do you have anything in the manual that shows a computational cell, one cell, and showing how does the conservation of mass apply on this cell, and how does the conservation of momentum apply on this cell, showing the velocity? Do you have that kind of diagram in the user manual? So that gives you understand, that gives you explanation how the flow is distributed.
I think I wonder if that would answer your question, or if I understood it correctly. So, but what I showed here, that highlights those information that you were asking. So, suppose that is the cell side that I have here. So, if I zoom in further, the green layer is the terrain model. So, and you see there are some pattern here that has a lower resolution than the greater cell. And if I go to the other side, you see those dots, or those profile that is the terrain model profile that's cell face crossed in that image. And you can also, as you ask, if you want to see the volume versus elevation pattern, or other hydraulic properties. We did not run the model yet, but for each side of a cell, you can go and find out what is the time series of the velocity, what is the time series of flow area. You can extract them out after you run the model. But these are just the basic geometric information. We did not run the model yet. Any question? So, oops. So we can go back to one of those boundary condition lines. You have a question?
Yeah, so how do we find the boundary line? Because for downstream, there are two boundary lines, but I think the river only across one of the boundary line. Why there are two?
Okay, so suppose, if I understood it correctly, suppose that you have something. I wonder, there is an area. There is an area here, although there is no river directing to that area. But yeah, you may just check out something that is important here for you, and you want to see if there is any flow is coming over here. You want to check out what are you want to assign something, not just check out the outflow. You just want to assign something here, like a cross section or something that you may need to specify at that break line, or that's somewhat like a break line, but you convert it into a boundary condition line. But you're asking whether why we are assigning a boundary condition when there is no river passing through it. So that's what I'm saying, that you are looking for you are trying to assign something here as a user-defined boundary condition, because water can flow away based on physics. But you will say, I want to have the stage water to be fixed here as just 2 meter or 10 meter. You have a reservoir that you are assigning a stage of water of 10 meter. And that means when you have a flow coming to this boundary, it will recognize there is the elevation here, and then it will turn the profile into something else than where you have no elevation of water. So you are enforcing a particular boundary condition to some point to manipulate the flow pattern. Is it? answering your question? Okay. So I was at this point that suppose that we are going to, oh, what's happening? Cancel. So maybe I need to delete this. Okay. So view full plot. Oops, we have a problem here, but don't worry. So I thought I turn off the boundary condition lines here. Or no, it's okay. But oh, okay. Because I did not define any boundary condition yet here. So let me just first resolve this red dot issue, and I will be back in a moment. So okay, then okay. So I'm going to add those break lines, not break lines, boundary condition lines, the upstream and downstream. They're not there yet, so in order to add the boundary condition line, I showed that you should go to this, that is SA to the area BC line, that means boundary condition line. So it then when you click on that, the cursor would look like a pen again. And then you can start from wherever you want, say from here, just click, try to be exactly at the top of the ending line. It doesn't matter if you just go a little bit up or down. At the end, HEC RAS itself would adjust it accordingly. So once you're done by drawing it, just double click on that. It will ask you for a name. So I would call it upstream BC. Click OK. So you have it like this. Let's just play with this, and it's the same for the other boundary condition line, upstream and downstream. So when you click on that, it will give you these options. So you will have these options of editing the boundary condition line name. You can plot stage flow hydrograph, but for the time being you have nothing because we did not run the unsteady flow simulation. But you can plot the terrain because there is a terrain over there. So that will give you also a snapshot view of the terrain model. So I think we're good for this page. Let's go to the next page. So now let's see how we can add a flow information like flow time series, stage time series to those external boundary condition line. In order to do that, you should go to in the same page, not in the same page, in the original page or original step where you have all these options in the main page. Just go to edit. So in the edit you have these options. You have geometric data, you have steady flow data, quasi unsteady flow data, unsteady flow data, sediment data, and water quality data. For the time being, we are talking about 2D flow analysis. So sediment data and water quality data are belonging to 1D in HEC RAS. They did not put anything new for the 2D flow analysis for these two options. But a steady state flow regime also is not applicable for 2D flow analysis in HEC RAS. The only option that remains in the unsteady flow data. So you go to unsteady flow data. So the only thing that is existing here is the one that we already generated, the upstream BC. So in the upstream BC, if you click on that, so these options will be turned on. So that means you can add stage hydrograph, you can add flow hydrograph, you can add rating curve, and also normal depths. But we rarely put normal depths in upstream location. So we will just add something like flow hydrograph for this boundary condition. So if you click on the flow hydrograph, that page will come up. Okay, so you have this option to add the time series in cubic per second as a unit at this column. So if you're lucky, you have a spreadsheet data that have this information, you can add them according to that. What should I do now? Let's say I put 100, 200, 200, 300, 300, 400, 500, 600, 700, 800, 9, 8, 6. So you can also specify the time interval, the data time interval. I'm okay with 1 hour, and you can say I have a time series, realistic time series for which I have a real time. So I can say I want to start from 2017. What's that today? 25 of February. So, okay, we're here. So I add this as this, and you can. That's a military time. You can say I will start from 000, and then you will see this to show like a real time in this side. So you can also see how the flow hydrograph would look like just by clicking on this. And just click OK. So it's there. You can also specify an initial condition for the flow simulation. Say we're gonna start from 100 cubic feet per second as initial flow, or also for 2D flow analysis, you can also specify an initial elevation for all the cells of the domain. But we rarely do this. We can just leave it as it is, as a blank. These are for sake of warming up the model. That means you can start the simulation while the whole domain is dry, or you can start the simulation to some point when water would fill up the whole domain, and then the real simulation will be started next after the whole domain is filled up with water. You can also specify that warm-up time. I will explain it later. So I will leave everything as it is here. So I need to save my unsteady flow data as something. So I will go to the file. I will go to the file and click on Save Unsteady Flow Data. So it will let me to save it somewhere. So I will generate a new folder within this Bald Eagle Creek Multi-2D underscore test, I will call it unsteady flow data. So that folder is generated. So within that folder, I want to save that file as unsteady flow data draft. So just click OK. So everything is there. So suppose that also I want to add another condition at downstream point, but this time I want to add normal depth. Normal depth means a hydraulic slope. It's not a depth, actually. And it will solve it by means of Manning's formula. So adding a boundary condition line, starting from here, here, and here. So I will call it downstream BC. Click OK, so it's there. Now if I going back to the same unsteady flow editor, go to edit again and unsteady flow data. So see, you have this new row that belongs to downstream boundary condition, but the boundary condition for this new guy is empty, so you need to add something. So if you click on this empty space, those options will be highlighted. So this time I just click on normal depth. Let's see what will happen. It will give you this little window to say what is the friction slope. So I would personally use bed slope as friction slope for some places. So I don't know what's the slope over there, but suppose that's 0.001. So then it's assigned to that. Save it. So we also in our domain had something like this guy, that is internal boundary condition or internal boundary line. You see it's a little bit different from those lines in terms of outline. You see a kind of a grayish, thicker line behind this. So that's actually a dam. So you add or define a dam at this place. And it's different from what we had done so far. So suppose that you had add this dam or add this internal boundary condition inside of this. And let me do that for you. Oh, what I'm doing. Okay.
What's the value of slope?
What's what?
What's the value of friction slope?
You know how to generate in hydraulics we have some ways to produce water profile. So one of the ways to produce water profile is to know what is the bed slope, and then based on that bed slope it will back calculate that it's differential equation. It will solve that differential equation, and in differential equation we have a term that is slope, that is friction and bed slope actually. And by putting that, while it's solving numerically that partial differential equation, then it will generate a new profile of water for that.
What's the value used?
What's what?
What's the value?
Somebody who doesn't know about the stage hydrograph or outflow hydrograph, you just can use the bed slope or say friction slope and let HEC RAS produce that for you. or simulate that for you. So now I'm going to add the internal boundary condition line here first to represent the dam. So you'd better not to touch the outer line, so just try to put it inside the 2D flow area. So I'm going to start drawing it. Okay. So I will call it internal BC. Oh, what is going on? Okay. So maybe, oh, because, okay, I got it. It was not the way that we should add that. We should define, oh, okay, inline structure, okay. Yes. So in that sense, you should, I was wrong. In that sense, you should add an inline structure. So go to the option and add an inline structure. But why is that? That's odd. Oh, maybe, oh, I'm sorry. Okay, I should do that. Maybe that was the case, okay.
So, does it has to follow the...
Sorry, please say it again.
Does it has to follow the cell interface, cell face?
I don't think so. You can put it inside of those. But I was wrong in selecting those proper options for adding that inline structure or inline boundary line. BC. I'm hoping that is okay. That's the case. But it's not well aligned to the one that I'm looking for. That's because I need to first add a break line. So that's good to see. So if I delete this connection first, I need to add the break line like this. When you add a break line, then you can add that boundary condition at the top of or along that break line. So double click on that and I call it inline BC, not BC, just break line. Okay. So let's enforce this break line into the system to look like this. Then if you zoom in and then try to add that SA/2D area connection along that break line, start wherever you want, but be within the range of those break lines. So I'm trying to draw them along the break line.
So to draw the break line first?
Yes, you should draw the break line first, because then those SA2D area, as I had done that before, you detected that there will be some kind of weird pattern. So that means you should define or align these sides along the break line. Then that boundary condition also would be align itself along that break line.
Just asking about the question first.
Okay, sorry, I did not understand.
Thank you.
Okay, reach the endpoint. So when you reach the endpoint, just double click on that and name it something. Say inline EC. Click OK, and OK, we are good. So so we have our inline boundary condition like this. So when you click on that, it says connection inline BC, so we're good. We have it. You can edit cell spacing, so that's good to know also. You remember that we define minimum maximum. So I may say, let minimum be 50 feet and maximum be 100 feet. And enforce it. Okay. We have some problems at some cells, so we need to resolve those first and then go further. So I just add one cell point here, and let's jump to the other case. Add and just click on the add points and we're good. So now if you go back to the, I wonder if you can jump to that point from here, but I don't think so. Okay, we're good. So what I did was going into that, just click on that inline boundary condition. Just one click would bring up these options. So just select that edit connection. So it will bring up this. And if you want to just generate a DAM, you can give it some information like if you have center line GIS coordinates of the crest of a dam, if you have something for that, or you can give it some weir embankment information here. Also, you can define the type of the weir. If it's
can you put this slow because we have to
oh, okay. Sure. Yes? Yes. It did not do anything wrong. I missed something to say first, then that should happen. But it's good to happen because you see when you see such pattern, that's because you did not align the cell well. Yeah. I suggest you to just click on that. Not blurry. Just click on that. Click delete connection. Yeah. So the thing that you should do. Oh, you add red line? Okay. So that's good. We are one step further. So you just need to enforce this break line. You just change the alignment of the cell. So now you're good. And when you are not up to this point, now you should go to this and just draw it along with this line. Then at the end, because these cell faces are aligned with that new break line, the new connection line also would adjust itself with that. Yes.
Oh, you're so. It's a religion. I mean, you are.
Oh, okay. I see what you. Because this is just a solid layer. It's not a sophisticated layer. It's just a solid layer. So you should go back to here. Oh, you have. I guess you have some problems on the geometry paper. You did not resolve them yet. Let's see. And you did not generate any mesh before. So, but I just going to just remove this larger part of the polygon for the time being and just stick to that smaller polygon. That would be better. And what is that? What is it? Actually, that's wrong. Did you generate another breadcrumb out of this? You do not do that. If you don't have any boundary conditions being added like this, so you don't need to. So I also want to delete this. So I think now we are at this point. We can just add boundary conditions as I said earlier. You change breadcrumb position. That's what I wanted to say later. That is risky because yes, yes, but you should define it as one side. Yeah. But at the end of the day, yes. I said 1,000. It's fancy value. I don't think it's realistic, but in real life, it's better to not get it as a normal depth. That's for the cases that you don't have any information about the outflow. So, but when you have an outflow time series, just add time series as a boundary condition. Okay. So that's breakline, right? You should
get less to do.
I believe.
Yeah, you know, I give up calling it. But it's not the same.
Yeah, and I decided
But it's not like.
Because I have done that here. You should add a go back to RAS method and turn that by off and then get train model beyond. And
So let's continue. I want to add dam information in terms of the height of the crest to this terrain, as you see on the board. So I don't have a height elevation, so I need to go back to one of those files that I had earlier and copy and paste those information back into this page. So I want to add something to the station and elevation here. Representing, yes.
When you mean station, what does it mean actually?
Okay, it's from, based on, that's a good question. So based on the direction here, it flows going from this side to that side. It's from left to right. It flows from coming from up to the upstream to downstream in this way. That would be your left side, and that would be your right side. And always regard in HEC RAS from left to right. That is, if that is your direction, always consider from left to right, whatever you are trying to add as breakline or something like that. Otherwise, it will show you something like negative values. That would happen. So, let me bring in those data that are belonging to that dam. For that thing, I need to open up another HEC RAS. You should not do that. I just want to do it by myself. I want to open up another HEC RAS session to see what are those data. So how should I do that? Oh, okay. So going back to here. So it will ask me when you. That's a good thing. You can open up multiple HEC RAS sections simultaneously. But while you click on one of those, it will ask you there is already an instance of HEC RAS. Are you gonna do another session? So you say okay, and I will open up another HEC RAS session. And where is this? Oh yes. Desktop, data, hydraulics, and this one. So now, back to this place. If I zoom in, so I want to generate something like this. So that this is my dam, and this is the what you call it, the gate of dam. So going back to that weir embankment information, so I'm just selecting these station elevation data. As you can see over here, just check out this plot. So starting from 0 up to 68,000 feet, that gives us the information of the elevation of each of those points. So I'm going to copy them first, just hold control and press C, and then going back to the other original session of HEC RAS. Where was it? Oh, it's here. So then I'm clicking, oh, maybe I should close that first then. So I'm closing it, and so I'm going to, but why is that?
It's already open.
Yeah, I think so. So let me do it again. Oh my god, I'm lost, so I'm totally lost. So let me just see. Okay, that was my case. Okay, so now I'm going to add this here. Yeah, and for time being, it's gonna be okay, something like this, but I may need to change something for the gate. The veer coefficient is okay. The veer width is not there, so I need to go back to that side again. Let me. What was that?
H0.
Oh, you saved that? Thank you. 80. Can I put just 8? So 8. Oh. 80. Okay. I thought maybe she's saying she says 8.0. So, but nothing's happened. Maybe. But maybe that's Crispr must be 3.1. These are the headwater and tailwater connection. You can also add headwater or tailwater connection to this by going back to the other side. So let me just close this one and then going back to the other side again to see. Ah, sorry. Okay. I think when I change those headwater, tailwater to okay, so this is OG, so 12, 20. So this is the headwater clipboard. Here. And then I would turn it into OG. Oh, I cannot change him? That's odd. Oh, I cannot change him. Interesting. Maybe I can import them. Mm-hmm. Okay. But let me bring in those information. So I think the spillway approach height can resolve that shape problem. So let me just close these pages. So it says 1220. Okay. What is about CD coefficient? No, it's okay. 1220. So and let's see if you have a breach data over there. So we have breach data plan like this. Oh, wow, it's so many things to be added. So, but in here, just let's observe over this page, not going to the original one. So you can add a center station. You can say where the breaching will happen. So the breaching will happen here. So this will look like this. This is a gate. So you can also not the gate. Sorry, it's where the breaching would happen. So you will say if there is a breaching, these are the places where the breaching would be initiated. So, and you can define the failure mode. It's piping or it's overtopping. So this is like piping, not overtopping. And also, you can generate a trigger failure just for the water surface elevation, not just the time of the failure. otherwise you should define something, a start time and end time of the failure. So, but for that case, we just need water surface elevation that caused the failure. And these are those information that you can say at what center station. That says 5250. That means it would start somewhere here. So if I left the cursor at this point, you will see that at the top you can see the coordinate of that point. And if I go further up to this point, below this something like a breaking point, it becomes like 5255. So it's somewhat like that center station. So you can define where that breach happens. And so these are the other information about the breach wear coefficient, back to the breaching formula. And you can assign all these things and define the breaching scenario. But it's a little bit complicated and it's out of the scope of this current class. So I think the breaching is similar to 1D analysis. Those who are familiar with 1D analysis of HEC RAS is exactly the same. It's not something different. So I may close the already pages. So now let's get back to our remaining works. So suppose that we had added this, say, dam, and it's geometrical information, but we need to add a boundary condition for that dam. So going back to the Unsteady flow data editor. Oh, I did not enforce that there. Oh, I should enforce that. I did that. It should be there. I don't know why it's not there.
You need to add it. Essay connection.
Oh, yeah. I just confused that. So yeah, you should add SA. Okay, yeah. I forgot that. So it's there. So now you can, if you click on this, why is that?
You needed to add the essay connection of the essay.
Oh yeah, maybe. Okay. Oh yes, you're right. Yes. So I need to get rid of this guy. But I think it would not affect if it's there and it's okay. It's delete boundary condition. So okay. Yes. Thank you. So at this point, if you click on the inline BC, you can see something called as rules. So in that rules, you can specify those types of information about the gates and about the time series of the flow passing through the gates. Maybe I need to go back again to that side to open up that original example that would give you more information on this, because I cannot memorize all those information for the moment. So maybe first of all, let's see. So if I go to the unsteady flow data, and that's odd, but because we have also time series for the gate opening here, but it was not the case over there. I don't know what I missed. These are all the same thing. Oh, I see. Maybe I need to add something. But suppose that you had that regular information that you may use for developing a dam infrastructure in that domain. These are the regular option once you do this properly. You might have that time series of gate opening also. That was I was looking for in that rules option, but it's here. So within this, you can say what is the time series for the gate opening height. So that means when it reaches 2 feet height, then that's the time for the gate opening, and it would be about 4 days or something. And you need to add a gate, because I did not add a gate. That's why it was not there. So in order to add a gate, that's what has been missed. So I need to add a gate to this. How can I add a gate? Oh, viewers and gates. Okay, so yeah, okay. So in the gate, then you can add the gate. So let me go back to this. And let's steal those information. So it's a sluice gate, and it is 0.60. 0.8, and height is 15, width is 7, inverge is 593, and opening number, we have 2 opening. Okay, one start at 52, 58, that's the center of that opening, and the other one is 5278. So, and we're good. I think we can go back to that side again. So 52, 58, 52, 78. Height is 15, width is 7, and this is 593. That is 0.65, and that is 0.8. And that is Lewis, and everything is okay. And we added that gate here.
Can you show how to add gate again?
What's that?
How to add the gate?
Okay. You should first define the structure type. If it's a weir and gate, then you should add that. If it's just simple weir, what's that? Yep, there you go. So that means when it reaches the 2 feet height, the gate will open and say, let's go out of the reservoir. And I think after this, we will have that option as you see here. See, now these are added. The gate. Yes, overwrite. And then you can add these two, but I want to be similar to what we have over there. So let's go back here. Just say how many of them. Just copy them. Close this. We don't need that too. We don't need that too. So, oh no. Good. So it would look like this. Okay. Apply it. Save. So we are ready to run the model now. So now let's close all these redundant points. So apply the data and then close this. Always click on apply when it's on. So then, so ready to go. Let's see what we have on this page. Let's stick to these rules and then we can run the model. So yeah, this is what I had done. I added upstream and I added downstream points. This is how the flow hydrograph is supposed to look like if I insert them correctly. So it's somewhat like this hydrograph. And for the upstream station or boundary condition. And for the dam infrastructure, you have something like this. And the information about the time series of gate opening as we added. And you can, as I mentioned it earlier, you can also add an initial flow for the system, or you just can leave it as it is. Let it start dry. But it is now an important part of the modeling session that you need to define whether it's going to start dry or you're going to define a warm-up period to let the system to be filled up with water and then be stable, and then let the real modeling to start. And or you can generate a restart file based on what you had done on different modeling, but in the same domain. That really happens because it's really complicated. And the other option is that you can just define them directly. Say you have a time series of 60 days or 70 days, and the initial period of 5 days or 10 days are uniform flow, just 100 cubic meter per second up to it reaches a kind of a flooding event. So you can say, I want to run the model for warming up as a warming up period for the first 10 days or 20 days of the existing time series. Let the water fill up the domain, and then after that 10 period, when everything is okay, then start again from the beginning and just do the simulation. Because at this point, the river is filled up with water, the domain is filled up with water, and everything is normal. And then you're not exactly starting from a dry condition. So I will do that right now to show you how you can generate a kind of setting, initial setting for your modeling. And that's the last part that you can do. And then you can easily run the model. So, oh, I should not close that. But I wanted to close this one. Okay. In order to set up that computational settings, you need to first open up a unsteady flow analysis running or executing window. So in order to do that, go to the main window of HEC RAS, and in the run option, just click on that, and you have steady flow analysis, unsteady flow analysis, sediment analysis, water quality analysis, and so forth. The only thing that is applicable in 2D flow analysis, just a single 2D analysis, I can say, is unsteady flow analysis. So just click on this. So it's nothing's here. So you should define first a plan. Name a plan. So you define a new plan. I don't want to overwrite or save existing because there's no existing plan. So I say no. So I want to define a new plan. And for that purpose, I want to also generate a new folder where I want to save my other plans in that folder. But I want to have them in a different folder or different repository. So I will call plans or say plans. So I will call it unsteady analysis draft. So click OK. And you can also add a short name for that long name. That short name will come as an ID while you're mapping it in RAS Mapper. So then you can have it as a short name. Do not put something longer than 16 character. So I will call it plan draft. So you can specify a geometry file. We had that as test 2 where we have that 2D flow area. The others does not have 2D flow area, so do not put them here. Or do not select them, I mean. And you need to define an unsteady flow data, or those time series that you had just generated. So we only had one, so this is this, and you just select it. You want to do the geometry preprocessor. You want to do unsteady flow simulation, no sediment because it doesn't work in 2D flow area, and post preprocessor. About the flood mapping, it's already produced flood mapping, but this guy is a little bit different. It's a little bit more complicated in terms of producing so many data for each grid cell. So if you want to produce so many data for each grid cell, that will take for a long time. But a regular run is just to select those options and just let it run. And it itself gives you enough information at the end that will be necessary, not just redundant. But the floodplain mapping, we also produce separate files for each type of run, and it's a really messy outcome. But for those that working with the giant projects, maybe that would work for them to have them as separate file. So you also need to specify simulation time window, starting date and end date. You need to go back to that unsteady flow data that you had generated and start with a flow hydrograph for the inflow at the upstream. See when it would start. It start at 24th of February 2017 at 24. I mean that's 12 a.m. So I will say 24 Feb 2017 and then 24, and the last date of the data in our time series is 25 2017 of February 2017 the 9 p.m. So 25 Feb 2007 2100. And then you can that's the most important part in that window to be specified. You can say my time series of inflow is based on hour, or it's hourly basis, So the computational interval means that you had something like, I think I passed that page, but I want to go back to that page because that's important to show you. Or maybe it's not there. Oh, sorry. I was wrong. It was exactly at this page. Yeah, that's it. So these are the equation that HEC RAS would solve. This is the diffusion equation. This is the Saint-Venant equation. You need to define the delta T and delta X. So we already defined the delta X. These are our cell size values, computational cell size values. But the delta T is the one that we should specify here. This is the computational interval. This is the delta T. So you should be careful about that because that condition should be satisfied for the diffusion wave equation and for the Saint-Venant equation. It's based on what you're specifying. We're going to say how we can specify whether it's going to solve diffusion wave equation or Saint-Venant equation. But suppose we are solving diffusion equation. For that, if the delta X is about, as we had as a default for the cell size as a 200 feet, the delta T must be defined in a way, given a v as a velocity. Suppose that the velocity will not increase more than 5 meters per second or 7 meters per second. But that condition must be less than 2 to be stable numerically.
Are you guys using the implicit scheme for that one?
What's that?
It was my understanding that
Implicit, yeah, it will.
if it's implicit scheme, then why didn't we impose the current criteria? What is the reason for that one?
That's a really good question. The reason for that is that it's still stable. It will not be unstable, but the accuracy will depend on that. Accuracy will change in terms of this.
But it is implicit scheme then.
Yeah, I know. The implicit scheme does not mean that the model would fail, but the final answer will not be accurate if you're not below. For example, there's something called Crank-Nicholson scheme. So the Crank-Nicholson scheme is kind of implicit, or but that will also says there is a bound for the delta X and delta T. And if you're within that bound, the accuracy will also increase. But if you're beyond those bounds, you should be careful of your answer. That might not necessarily be accurate or reliable.
Number criteria. Because when you're implicit scheme, if you go for last time step, it tune down your body weight, it reduce the weight. It's a very high restriction for that one. It's very high restriction.
Yes.
One you can have to have a time step very small.
Yeah, and then it was suggested here that while you are running a model, you need to first run an initial model to just find out whether you have any instability in your model outcome, and then go back and rerun for those locations when you have smaller cells and say, what if I change the delta T to something else, or just changing those cell size values.
But let me get back to that place again. So I was trying to show you how you can set up a warm-up period in HEC RAS. So suppose that based on my time resolution, which was hourly basis, I think numerically, just suppose that 10 minutes is okay. And I want to, as I mentioned, that the RAS mapper can produce a time series of animation of flood propagation. So you can here specify for each flood layer associated with each time, what is the time step of that. So you can say the mapping output interval is based on hourly or 2 hour or say 1 week or 1 day. So you can define it. But it should not be less than the time series of the inflow. the resolution should not be less than the time series of the inflow. Because I have hourly time series, so I would define it as a 1 hour. And these are similar to 1D analysis in HEC RAS. So you can say the output hydrograph to be shown in each point is based on 1 hour, or detailed output can be based on 1 hour. You can even have them as less than 1 hour, but because the inflow is hourly, it will interpolate or do something to just give us information between two steps. So it may interpolate to give you that. And I think that's it. So you can run it, but prior to that, you need to define a warm-up period. In order to do that, go to that option and see if you can find a calculation, options, and tolerances. So if I click on that, you have 3 tabs here. General 1D option, that's about the 1D computation. It doesn't affect this calculation because it's pure 2D. So we are just going to the pure 2D flow option. So in here, you have a default option, and you have an option associated with that 2D flow area. If you have multiple 2D flow area, you may have multiple columns here. But because we have only one 2D flow area named 2D flow area underscore test, we have only one beside default column. So the thing that I'm going to keep is theta warm-up, and water surface tolerance. These are okay. The only thing that I'm going to change is the equation set that currently is diffusion wave. You can turn it to be full Saint-Fanon equation. I will not suggest to do that for the first run, because 2D full Saint-Fanon equation will be really sensitive to any mistake you have made in terms of specifying wrong cell size. The first thing is to just let it run by means of diffusion wave that is more simpler than 2D Saint-Fanon equation. And if the model seems to be okay, then you can just try it for this full Saint-Fanon equation. Also, some people would do that. Remember I mentioned as something like restart file? So you can run your whole model as the diffusion wave equation, save it as a restart file, and use it for running a full Saint-Fanon equation, and use that restart file that is made by diffusion wave as one of your conditions. So, but now I'm set it as a diffusion wave. So these are the most important thing than diffusion wave equation, that you can define an initial condition time series. You would say that if I have 60-hour time series or 70-hour time series, just say I want to have 20 first hour to be specified as initial condition time to warm up the model or to fill up the domain with water. The thing that I suggest you to do, first let it to be 0 and let the model to fill, or let the flood wave to travel in a dry zone. See how much time would it get for a flood wave to travel from upstream to downstream. It takes about 20 hours. Then go back and rerun the model, but this time put that 20 hours for this condition. And then let the model run to pass the flood wave up to the end. And then when it reaches that time, then the whole thing will be restarted again from the beginning. But this time, the whole domain is filled up with water, and it's realistic, more realistic. And that's okay. You can just see how it would go. The initial condition wrap-up fraction is nothing, but you can just say what fraction of that 20 hour also can be used for some other calculation, for other hydraulic calculation. So
it is the fraction of the initial condition time?
yes, this guy. Yeah. So I saw in some literature that people use half. Just oh no. What is this? It was empty, right? Oh, it was 1. Yes. So I think everything is okay for now. You can just click OK. And let's check out for the last time that everything is done. Let's go back to this. Yeah, I just explained what are these meanings. So I exactly did whatever I had here. So now it's time to execute the combined 1D, 2D, or it's just 2D for now. So these are somewhat an explanation of the way that HEC RAS 2D will be computed and will be executed. And there are some obvious situations that the full momentum equation should always be used. That's the most important part of this page. Where you should use full momentum, that is Sandfin full Sandfin equation, and where you should not necessarily need to use full momentum, because executing full momentum takes a lot of time than diffusion wave. But for cases when you have high dynamic flood waves, for example, dam breaching, flash flood analysis, or you have abrupt contraction expansion, like in areas of very abrupt contraction expansion, or you have a tidally influenced condition like modeling a bay, estuary, or we have a general wave propagation modeling, or you have super elevation around bends, like a tight bend in either a natural or design channel, and you want to see if there is any super elevation of the water surface on the outside of the bend. These are the cases that you should run it as full momentum than diffusive way, because diffusive way is a simplified form of a dynamic, full dynamic equation that does not contain acceleration terms and Coriolis term that is required for these particular conditions. So I think we had done all these things, and I think we can just go back and execute the unsteady flow analysis, and let's see if there is. So as I said, if you want to run it, you should go back to the main window of HEC RAS, go to the Run, select Unsteady Flow Analysis. That page will come up, fill up those options as required. And I also mentioned when you would need to click on this option. And it says that if this option is turned on after the program has completed the unsteady flow computation and the post-processing, the last thing it will do is run a separate process called compute flood map as an executable file in order to generate a depth grid of the maximum inundation that occurred at all locations in the model. That means all the cells. And I have suggested that this option is not required for flood mapping. If you don't have enough time or you don't want to put more burden on your model or machine, just do not do that. And these are where you can define the computational intervals, delta t, and delta t for mapping output intervals. You can just read those if you want to get information about what you should do. So now let's go back and run this. This is the outcome of the run. It was said it is done successfully and give you some information about how long does it take and what are the givens and what are the outputs. Let's go back to HEC RAS. I hope I will not receive any error. I have received some error. So that's good, because you will see what it would say. So it will say, just read these things, boundary at SA and boundary at SA connection. So it says the upstream BC EGS. Oh, okay, good. So I should define an energy slope for the upstream boundary condition. So going back to here. Okay, so let's click on that. So when you click on that, you are able to get inside that. If maybe not there. Maybe I should go back to, yeah, I was wrong. I should go back to here, edit, unsteady flow data. So I need to modify something in the upstream condition. So I need to go to this row, click on flow hydrograph, that will pop up. Below of this window, you see something here called EG slope for distributing flow along BC line. I would add something as I added for the downstream as 1,000th, or one, it's not 1,000th. Yeah. Click OK. So what was the other error? Said time series data ends before the end of the simulation. So let's see. Oh yes, because we just copied and pasted from some other sources, and that makes that problem. So this time series is this. It starts at 24th of February and ends at 25th of February. And here it starts at 24th of February, but it does not end at 20 something of maybe, okay, 27th. Okay. Yeah, and I mean the it is per hour. It's per minute. Okay. Yes. I mean I need to. It should be per hour. Yeah. Okay. Where's hour? Okay. But still we have problem here because these are not okay. So I should end at 25th of February. Time must be 20.
No, it's working.
Oh, yours working? Okay.
You have enough time right now. Did you increase the dimension 1 hour?
Yes.
Okay.
Everything is 1 hour now. So first we should save it. And then we should go back again to the this page and click on compute. It's working. So it's running now. I wonder how long does it take. I just hope that it will be fast. It will be fast because we did not specify anything extra. Yeah. Oh. Something is wrong. So at in okay, it has a great gate lower than the cell it has connected to. Oh. So I may add this cell elevation, so it's okay. 6273. So going back to this. No. Going back to that. Oh yeah, that's the problem, I think. Yeah, I should change it to something else. The lower elevation must be changed to something else. Probably something larger than that. Maybe I would put 635. That looks better. And I definitely know it would work now. So let's see. Everything's set. So and then boom. Now what's up? Should not be lower than that, so maybe.
You showed the profile. It seems there were maybe a cell that was higher than the dam.
Yeah, that's the case. It's no, it says that the terrain cell is one of the terrain cells.
Yeah, show that profile.
Yeah, I'm going to do that. Let's see.
See, you have on the left, you have
Yeah.
that cell over there.
I mean, the thing is that this should not be below the train. It should be so the train is way up. That's the train profile, but it should not be that.
Just make it a little bit higher.
Yeah. Maybe.
No, not that. I think it's the dam itself.
The dam?
It's-
Okay.
yeah. I think
So I may elevate this. Where maybe you're right. So what should I add? May make it as 7. Oh shoot. If it didn't work, I would go back to that main HEC RAS and then let's run that to see if it works that way. It did work that way in my machine, but let's check it out if it's okay. And hope it works. No, it doesn't work. So I suggest to go back to that HEC RAS model that we have more information and better settings. And let's run that. So everything looks fine here. So let's say, oh, first of all, let me. Okay, that's the end product, not. But I wanted to do something like this. So, and let's run it. it happens because we did it so fast. I may miss something over there, but it's all instructed well in that slides that you should follow. But I wonder at what I missed. Let me just close.
Shahab, do you know if they are running the 2D simulation of like outside of the interface, like on a supercomputer or anything like that?
Yes, actually, when you're asking whether you can run it on a different CPU or something, or
Yeah, like on a supercomputer, Linux-based machine.
I think you have.
It's another question. Like,
I just want to show you something. So you see this, this is a 4-core. So this is a 4-core computer. So you see all 4 cores are processing right now.
Yeah, that's why I'm thinking, because it's parallelized,
Yeah,
you can really take advantage of really
yeah.
but not for Windows.
I know that 1D HEC RAS can be operated outside the HEC RAS domain in SQL, but I wonder if it's complicated in 2D. So it may take a little bit time to be finished, but if you have any questions so far, you can ask, and then we can jump on to the last page that, or last topic, that is how to visualize these outcomes. This is going to be so fast than whatever we had discussed so far, because this is, and really more funnier, because it has a lot of graphical fancy things that you like.
how long it takes normally on this?
It's 4-core. I don't know. It's not. It's gonna be fast. It's not. Maybe in less than 2 minutes, so, or 3 minutes.
Why it is showing this 21st January 1999?
This is their time series that would start at that, not at that point. It would start at the day of the 1st of January of 1999 and ends at 7th of January. But this is just for this domain.
We wasn't providing information on 1999. We have running model in 2000.
Yeah, I mean, I've done it for our case, but for these,
okay,
this
so,
problem,
okay.
yeah, it's different.
Hold on.
It's different file.
I think it was 2 days. This simulation. So it shouldn't take.
No, it's not going to change.
No, it should be done on January 4 in noon.
Yeah, yeah.
So I guess it's about halfway there.
So let me go to those pages that we just flicked through. Maybe we have something to show that might be interesting for those who had any question or. Yeah, you should be really careful of this if you want to have a better model outcome of these limitations, just for sake of accuracy. And so where are we now? Is it done? No. I could have run it just for not this resolution. I may just have run it for hourly or 5 hour, just for sake of. But
So that folder don't have the output already included?
this
That exercise
I think I had added those images, but we can just after the run is over, you can go back to the RAS mapper, close the current RAS mapper, and then reopen it, and you will see something different that as a new layer here in the result sublayer. Here, you will something new is added in the result sublayer, and then you can just go back to this because I did not run that model on this machine. It may have already, as Dr. Cohen mentioned, it may have that information here, but these are not okay. You should just rerun it, or maybe. Oh, maybe that's okay. Let's see. I can pause it. That's good to say. I can pause this run, not stop it, but pause it. And let's go back to RAS mapper. I think it's working. Yeah, it's working. Oh, good. So I don't need to run it the whole thing. So let's say I want to zoom out and see the whole domain. So let's see how it looks like. Starting from okay. So I think we are good. We don't need to run the whole thing. It's already there. So as I said, when the model run is over, something new would come into this layer as a result. This is called here as a single 2D as my outcome. You remember we have a short ID while we were using that unsteady flow analysis window. So that short ID here is single 2D. So in that single 2D, you have these options. These options are, if there is a magnifier, so you have geometry. These are the outcome layers that you can make animation from those. But you can add more layers instead of having depth, velocity, and water surface elevation. You can add more hydraulics to this. So let's show you how. So let's just see what depth looks like. So the depth is like this. So at the top of the RAS mapper, no. At the top of the RAS mapper, you have this bar that looks like this. So I will check out. I checked out those buttons in the beginning, but these are new now. These are new. So let's get back to our original page. So let's.
This simulation had a bridge. Is it a dam bridge?
Yes, I will show it to you. So start from time 0 if you want to animate this. So just click on that play button at the end. And it's the domain was originally dry here. So there you have dam bridge. And then it will end. So these max and mean button means that for each grid cell, what is the maximum water level depth or water depths or even any types of hydraulics. Here I'm looking at the depth layer. So that will give me the maximum of the depth value at each grid cell. If you can zoom in, you can see this better. See? You can double click on that layer and change the color or change the layer from to be stretched to discrete. So then you can say, want to generate this variation over color in 5 group. Then it would be like this. You can also add contours to this. Turn the color of the contours into red. You can also add these are the depth values at each cell. So you can look for those where you have high values. Instead of just as a graphical image, you can see the values as the depth at each grid cell. It's in feet, actually. And these are other messy things. You can see the face low elevation centroid. And the other good thing that I love so much is the velocity layer. So that's the velocity layer. Let me get back to the dam. Okay. So if I play this again, just click the pause. Then you can see the flow direction at each grid cell in terms of vector. Just click on that. So it's not clear, so you can go back to this that looks like a arrow, and okay, and then you can say the color of those arrows to be black or white. You can see the particle tracing speed, density, and the width of those arrows, and that's for this animation. You can see how flow would pass through these. You can see these vortex around. You can zoom in to see what is going on. That's what I did. You can change the speed of those tracings to so slow or to so fast, or their density to be really messy or just some particles. But you can change their width or to be really thick. So, and you can see the lifetime of those. They would disappear very soon, or they will stay for a long time. You can change their spacing also. So this is one thing that I should say. You can also add more layer to this. Just double click on single 2D layer. It will give you some information about where did it come from, based on what data, and based on what computation, and based on what plan. but I'm going to add some layer to this. So right click on that, and say, and go to that add new result map layer. When you go to this, you have more option than depth and velocity and water surface elevation. You can add inundation boundary, that's a polygon. You can add shear stress. These are other hydraulic attributes like depth times velocity to 2, and arrival time, and stream power. So you can choose, for example, stream power. And you can say, I want to add just a map layer based on a particular episode, a particular time. For a particular time, say, just the maximum of all cells, or the value of cells at January 2nd, 1999 at this time. So let's say maximum. Here, you can develop this new layer as a temporary layer just for inside the HEC RAS 2D. When you close the HEC RAS 2D, it will gone. But you can also store it in your hard disk or save it into a local disk as a raster layer or as a polygon. That's a shapefile. Depends on what you're doing to have as an output. So let's say, also you can add it as add a name for that. But prior to that, let's say add a map. So it's added. It's over there. So if I, what is that? Compute. Okay. When you see something like this that has this red asterisk at the end, that means you need to do something more. As you hold the cursor at the top of it, says stored map file not found. So you should go to manage result maps. It was here. So I went to tools in RAS Mapper. I went to manage result maps option. So it gives me all existing layers, and what I'm looking for here is for this single 2D. So it's here. That single 2D is here. So as you see, the store status for this layer that we already generated for stream power says map not created. So in order to create this, just select this layer or to select this row. At the corner right at the top, we have something as a button called Compute Update Stored Map. Just click on that. It will take time to. Let's see that I'm following exactly the same as I'm having here. Yeah, so I did that too. So everything is explained here. I also showed you how you can use this measure tool to just place a quick cross-section over the floodplain or whatever you had produced to see how water surface elevation would look like, or how here it just shows the terrain model. But if you have a flood layer map at the top of a terrain model, you can also have it here. I will show it to you right now. But let's see if it's done. Not there yet. What is happening? Okay. Okay. So, still working. Meanwhile, I think I can. No, I cannot.
Can I ask a question?
Sure.
How is this
I think that's awkward, but that's how it is. So you should select this if you want.
Oh, it's done. Okay. I hope it's done. Yes, it's done. Okay, we have stream power now. Okay, good. So that's how stream power looks like. It's a maximum stream power. It's a solid. It's a solid layer. And if I expand it, it will look like this. So suppose that I want to import it as a raster layer. And I think I did that. But I want to see where I did store that layer. You can go to layer properties. Not there. Yes, source file. So this is where you can find that layer, and that's VRT. That means you can add it into the ArcMap as a separate layer. So the thing that I'm going to show you here, that if I have a terrain model and also I had add water surface elevation like this, and if I go to that ruler and I make a cross section here and define a plot, that will look like this, but I'm supposed to add something like why it's not there? I just wanted to add. Oh, okay, I got it. Now here times to add profile lines. So if I add a profile lines, you should click on this plus button. So because flow is going from bottom to the up, you should draw that cross section from left to the right. So you can save it, give it a name. Okay. So if you click on that my XS, it looks like this. If you right click on that, you can produce plots, but if you turn on all these layers, but I may just turn off this guy and also this guy. So the depth layer is open, is on. The water surface elevation is on. So when you right click on that profile line and click on plot and water surface elevation option, it will give you this. So you have the cross section and you have a water surface elevation, and you can see where water where is the water surface. Yeah. And you can do this at whatever wherever you want. So for example, this guy or this cross section is along the channel, and you can also produce the same thing here, but not just time series but also other hydraulics like velocity. You can generate plots for velocity. It shows at that moment of the time that we have 3rd of January 1999, velocity profile along this line would look like this. You can also add another layer of velocity here, and you can make it for another date, and then add another layer here of velocity, and then compare two velocity of two different dates together, and you see if it followed the same pattern. It's good to know. Also, along that same line, you can get the inflow time series. Just click on that. It will look like this. It will before and after a flood wave. And you can have the table too. What else you can have here? You can have the time series plot of depth. It also looks like this. And let's see what else we can do. And you can also have a volume accumulation plot. So let's see if we are following those outlines. I did everything I mentioned here so far, so you're good. And you can follow these instructions if you missed something while I was talking. It's exactly the same thing, what we have here. We're about to end. Okay. Suppose I want to generate a water surface elevation. That's the last thing I want to say. Water surface elevation at the top of a train elevation along that cross section I made. So get back to the HEC RAS. Let's stop this guy and just forget it. So okay. So for this, I have depth. I have I don't need velocity. Just go to the plot and water surface elevation. That will give you this. You can see how water what's the water profile at that particular condition. We have max value for depth and water surface elevation. It's not at a particular date, but you can make it for a particular date. Say I want to have it for which date? I want to have it for 3rd of January 1999 at 2:50, and make it also 3rd of January 1999 at 3rd. 250. So now, and then go back here and say, I want to see the water surface elevation for this. So now, associated with that time. Yeah. So I think I'm done. If you have any question on this.
Thank you.
Thank you. So, I wonder if I have. Do you still want to work with HEC RAS? Do you want?
Yeah, I think that's why you go back and call, because I think I need to do the same thing.
Just the macro itself is very impressive.
Yes, yes.
I mean, it can do stuff that would be very difficult to do with like ArcGIS.
Exactly, exactly. What I love about this is animations. What it will do.
Nothing new.
Oh, it's cool. So do you have to have both an upstream and downstream boundary condition? Or can you just put one?
No, you should have it.
Otherwise, just come up.
Yes, yes.
Has to have an outlet.
Yeah, you should have both upstream and downstream.
And initially you had the river line. Is that necessary or not?
It's just for
sake of if you want to add a cross-section and a raster, you should develop it from that river. But this is a simple 2D. You can also add other 1D elements to 2D, but they're not going to be inside the 2D. They must be lateral. Or even say the 1D is in the middle, but there are some 2D cases. As I had on one of those pages, I may say this one is better than pure 2D. If I go to the... So these are the conditions that you might use.
You put in all the cross-section.
Yes. So this is the 1D flow, and you have lateral 2Ds here. You can add them.
How difficult to add them? Is it for
I think it's not difficult, but it's more practical than because 1D analysis is much more faster than 2D.
Yeah.
And you might not necessarily need to know what will happen here, but you want to know what would happen if water elevation is higher than some limits, and then you have some propagation of flood here, and then you add these to the area, not the whole thing as 2D.
Yeah.
I have a question.
Sure.
In the last, when you're trying to get your water depth profiles, you put a line. I can just show you mine.
Of course.
I think they're all here.
It's really great. Like, I love having those systems because they are like your own little army of slaves. And you just let them do things. It's great.
Well, it's
Yeah. Like, why did we use the lab?
I think it's fun.
Okay, because for mine, I think we're gonna have to, because everyone's gonna need our GIS, and they're not gonna have it on their laptop.
Maybe you don't need to reserve for resuming.
Yeah.
But then you will get it whether they can do it or not. If they can do it,
Are they doing it?
They make it free.
Okay.
You know, like they're free.
Yeah.
They make a fee evaluation.
yeah,
They will give you guarantee whether they can do it or not.
Okay.
You even provide them all the.
Oh, okay.
So we read ID.com. Like, how much is it now?
Yeah. Right.
Now, those I have my.
Some people want to have the cards.
Okay.
If you have any questions or something.
I'll keep it finish.
Sure. Thank you so much
And
for
I'm doing the same
Yeah,
test
that's
using,
fine.
you know, deep
Yeah,
learning
but mine,
deltas,
like, can't
stock
fit
model.
everyone.
Okay.
As I said, one D2D, you have to solve it.
Yeah.
Solve it.
Yeah.
Yes, like to like everything all actors necessary together. We have something in deep learning and solve it. Delta theory. Delta
Yeah.
so we're doing similar things. So
So Delphi is a similar model to
yes, sir.
Yes.
So they have a new model, D-flow FL, that is a combination of Delta theory and solving.
Okay.
US chart combination, extras and sum.
Okay.
That's good for 1D2D connection. That's
Yeah,
all.
sure.
So I maybe do some kind of comparison that will maybe. But I'll keep in touch with you.
Thank you. Sure. Of course.
That's good.
My pleasure.
I'll email you on that.
Thank you. Do you have any other contact numbers or contact information?
Yeah, yeah, you can have my.
Yeah, so-
I'll keep in touch with you.
Thank you.
Yeah, maybe you can coordinate with the
Great.
Okay.
Thank you.
Good luck. Good luck. Okay.
Thank you so much.
So are you going to travel back tomorrow?
Yeah, in the morning.
Okay. Have a safe trip.
Thank you so much. Hi, if you want to.
Oh, thank you. Actually, I have a question. So here, all this we have started from the project is already there. I'm considering that starting from the scratch.
Actually, I was joking about this that because of the limited time, I'm like a chef who is trying to make up or do cooking, but based on the limited time, you need to say, okay, these are the ingredients, and at the end, the product will be like this. So I try to just show you what are the ingredients and what you should do for setting up a model, but I showed you the end result in a different file.
But what I try to say, for example, this is like all. I mean, when you have the project file, actually it's already done something. Basically, I want to know that for example, you have a new project, you want to start with some river, some section of the river, then you start with the
Yes.
definitions of the channel.
For the 2D,
and
analysis, as I explained here, you definitely need a terrain model. You definitely need a land cover layer, either defined by you, by polygons, or coming from a source like National Land Cover Dataset. And you also need inflow information at the boundary, or
Yeah.
if you have something in the middle of the domain. And also, if you have some structures like levee or dam inside the domain, you should add, or you can add them. It's not necessary, but if you want to be more detailed, you can add them. And at the end, you need to run it as unsteady state flow. For unsteady state flow, knowing time series are the necessity of this type of simulation. It's not-
maybe the incoming.
Yeah.
Yeah, basically what I'm saying, trying to say is that if we really start from a new project, that means I tried actually. If you create a new project but you don't include some reading some project file, then everything is black, right?
Everything is black. Exactly.
Yeah, so if that's the case, then we just start from the geometry and put in the river, bank line, something.
If you were trying to make up the 2D model, I said in the beginning that maybe you missed it. You need to start with RAS mapper, because RAS mapper is the place that you would add a train
Oh, okay.
and also add kind of some outlines of domain or outline of the structures like land or levee. And then once you did this all, go back to the geometry editor and just define your flow area. Yeah.
Thank you.
Sure. Of course. Thank you. I'm sorry, guys. I need to help you.
Should I just never mind.
Actually, basically, this is what liquid into not putting trash.
It was great.
It was so fast, I think I wanted to be precise but not fast. If you miss something, blame me for being
Well, I can ask you my questions.
Sure. I thought Dr. Cohen told me that you need that HEC RAS 2D. Yeah.
Was it helpful?
Hopefully this trash doesn't run
Was it
here.
helpful? Oh yeah, very much.
Nobody
Take it
puts
from
the trash
there.
on. Okay. The janitor's gonna get
I mean,
down
you know,
on
with these things, the most important thing
so much trash.
is just to get kickstart, you know, just to know how to even understand what's going on.
I always learn programming or whatever kind of tools that I'm working with by playing with other people's examples.
Yeah.
Just see what will affect if I change this or what will affect if I change that option. That's how I learned this.